Morning, everybody, and welcome to IPC eTextiles 2020, a virtual summit. Glad everybody could make it here today. We really wish that we could have been at the University of Minnesota, but obviously based on circumstances as they are, we decided to still do this event virtually. My name is Chris Jorgensen. I am Director of Technology Transfer with IPC. I am also the staff liaison to the IPC eTextiles Committee, which is why I will be leading things in today and handing off to our first session leader. Just wanted to go through just a couple of housekeeping slides, and then we'll get into this morning's program. We have a pretty packed agenda for you. So first things first, just some house rules. So this is the first time that we are doing a web event like this. We typically use webinars, but we really wanted to replicate the interaction and the networking as much as possible that you'd get from a live event, which is why we're using Zoom meeting instead. What that means is that we need to rely on people to take control of their cameras and microphones. So if you are not a speaker, please keep your cameras off. Please keep your microphone on mute. We'll also be monitoring to be sure that it remains to be the case. We just don't want there to be any interruptions, be they accidental or otherwise. If there is anything where there are multiple interruptions from somebody, please note that we will remove you from the room. You can come back in, but we just need to be sure that in the interest of all the attendees and the speakers that we don't have interruptions. If you can, please put in your first and last name on your Zoom profile. Kind of think of that as your name badge. During the Q&As, definitely turn on your cameras. We really want this to be an interactive sort of thing. And also, we're going to treat today and tomorrow kind of like the Zoom meeting room would be a conference room at a hotel. So we will have networking time during, in between the sessions. So we're going to keep this room open for anybody to talk about whatever they want to talk about. Obviously today between 1 and 2 Central, we do have a planned networking thing to talk about some things with COVID-19, but obviously throughout the 2 days, please feel free to stay on. IPC staff will be in the room to monitor things just to make sure that everybody's okay, but hopefully you'll still be able to interact. If there's any questions or comments during today or tomorrow, please send a Zoom chat message to me or to Robert Erickson. He is the other person on IPC staff who is helping out. So first, a little bit about IPC. I know that we have quite a few people here today who are new to IPC. So welcome, first of all. We're glad you're here, and hopefully this will be the beginning of a long relationship with you. But just an update of just a little bit of information about IPC. So we're a trade association formed in 1957. We have 6,000 member sites worldwide, and we're dedicated to furthering the competitive excellence and financial success of our members who are participants in the electronics industry. So we do this in 4 general areas. One is international standards. We'll go into some standards things in a second. Education, like programs like today, advocacy and government relations, and also solutions. Solutions kind of a catch-all for industry working together to solve problems through IPC. So just a little bit before we get into things about our IPC eTextiles committee. This is a committee that is developing standards. And they've also developed a couple of white papers as well. So right now, we have 3 documents that the committee has approved for publication. The first was the IPC 8921 standard. That's for woven and knitted eTextiles. That is available in the IPC bookstore, as well as 2 IPC white papers. We have one about washability, and we have a second one about a framework for engineering. In fact, that second white paper was written by Maddie Maxey, who's our first speaker today. And you can get all of these documents from the IPC store. You see the link there, and we can provide it to people afterwards. In addition, the IPC eTextiles Committee has several activities that are ongoing. These are open to anybody for participation. There's no cost or obligation. You don't need to be a member of IPC or pay a fee. These are all open to anybody. So we have a group that's working on a guideline for connectors. We have a second group that's working on a design standard for printed electronics on eTextiles. And we have a group that is based out of not Germany, but based out of Europe, that is working on a quality and reliability standard for eTextiles wearables. We also have some new projects that are coming up. So we have a group that'll be working on a standard for conductive fiber, yarn, and wire. We are going to work on a revision to IPC 8921. We are also looking for people to volunteer for a new standard for eTextiles for high voltage applications. And in addition to that, the committee is always looking for new ideas for other topics. So if there's a need that you have for a standard, let us know about it. I mean, it's really easy for us to get a group going to start to develop a standard. One of the things that IPC is just launching, a lot of you should have received the link for this. Anybody who registered within the last couple of days, you'll receive a link soon. But we just launched what's called IPC eTextiles Exchange. This is going to be a free service for industry where it's a way for people within the e-textiles industry to share their knowledge and experience on things, and also for the industry to be able to collaborate. So right now we have some videos that are up there. These are video presentations and Q&A sessions. A couple that we posted up, we're calling our keynotes. Those are from Flex. So we have Yulito Wildman Nugent, who's giving a presentation. And I also was able to do a Q&A with Ben Cooper. Ben is also with Flex. You may remember Ben from his time with IO Close and other things. You'll also find this week, we have videos with Matt Combs with Supreme Corporation, Ken Arrojo with Namix, and Jesse Drew with NC State. We are going to be adding new videos to this monthly. This will be open to anybody to access, but right now we're just giving exclusive access just to the attendees here today. So really interested in getting your feedback on it. And also if you have any ideas for topics you may like to share. I also want to say thank you to the sponsors for this year's event. So this has been, you know, obviously one of those years where the sponsors would have had tabletops and things like that. So we really appreciate their support, because their support enables IPC to be able to reduce the pricing that we charge for people, you know, for attendees to be able to participate in the event. So Namix, Panasonic, Bayflex Solutions, and Valley Ribbon Mills, thank you very much. Also want to give thanks to our program committee. When we first started this event 3 years ago, the idea was that we did not want this to be an IPC staff-led event, but an IPC staff-supported event. This is an event that is put together by industry. So this committee, they're responsible. They put together the program that we have for these next 2 days. So I really appreciate their work. I'm going to read off their names left to right and then go into the second row. But we have Meg Grant, Stephanie Rogers, Carol Winterhalter, Mary Johnson, Brad Holshoe, Lucy Dunn, Anjali Kamani, and Erica Simmons. So thank you to them for the program they put together for us for the next 2 days. So with that, I'm going to turn things over to our first session. Our first session leader is Erica Simmons with AATCC. So Erica, I will let you do your intro and then I'll be ready to launch your video when you're ready.
Hey. Welcome to the IPC eTextile Virtual Summit 2020. I am Erica Simmons. I'm moderator for this particular workshop. I'm the technical director at AATCC, which is an international textile standards organization located in Research Triangle Park, North Carolina. This class that we're in covers e-textile products for consumer and medical applications. This morning, we will hear from 3 innovative and thought-provoking industry leaders and researchers immersed in the areas of e-textiles. I highly encourage you to take notes, as there will be some exciting and timely information shared. Please hold your questions for our panel Q&A session, which will immediately follow the last speaker of the morning. After lunch, we would like you to join us for a special networking session to discuss COVID-19 and how it has affected our industry and what's next. Our first speaker is Madison Maxey, founder and CEO of Lumina. Throughout her work at Lumina, she has done soft circuit work in education for Fortune 500 companies. Maddie's work has built the foundation for 4 patents. Her topic today is making it real, designing a product to fill the gap between breadboarding and looks like prototypes. Maddie could not be here for her presentation, so we have a recording, which Chris will play for us in a minute, but she will be available for our Q&A session to follow. So whenever you're ready, Chris.
This idea of making tools that can be useful. Hi, my name is Madison Maxey, and I'm the founder and CEO of Lumia. And I'm really excited to present to you today some research and development we've been doing, and this idea of making tools that can be useful for e-textile prototyping. I call this presentation Making It Real because getting to the point of having an e-textile product, getting to the point of making a real product requires a great prototyping process. And the goal of this product we've been working on is really to aid with that prototyping process. So my goal today is to walk you through our research in developing this product with the hope that it could be useful to you in your product development process. So this whole conversation and product really begins with coronavirus. You know, we've all seen this image many, many times, but for us, we typically work with R&D and innovation groups. Their budgets got cut with coronavirus. So once budgets were cut, we really started thinking, what's a product we've always wanted to work on? What's a problem we've always wanted to solve? And we started really thinking about the process of making an e-textile product get all the way to market. And we all know there are issues with production and scalability, but something that we've been working on quite a lot are creating looks-like prototypes. So kind of that green square in the center, in order to allow companies to get a good idea of what e-textiles can look like and test these prototypes either with customers or for technical specs. And making a good looks like e-textile prototype is actually a big challenge. You know, when you're making a works like prototype, you can just breadboard. So we can follow normal electronics processes. It's something that people do all the time. And when you're making a looks like prototype for something that's a soft goods product, clothing or otherwise, that's also very easily done. So, you know, you make a garment using textiles, you know what to do. But when it comes to making a looks like prototype that uses e-textiles, you tend to get these really kind of Frankenstein prototypes, like the one that's in the picture here, where you kind of just have to hot glue things together. You have a lot of wires everywhere, and those can't really be used for any sort of testing or user assessment that will give you really realistic data because it's so far from production. So we kind of wanted to understand if this was a problem that other people saw, and if this was something that could be useful for not just e-textile prototyping, but for making really high quality prototypes in general. So we put out a survey, and we had about 60 people respond from our mailing list. Most of those people were self-identified as creative technologists, followed by engineers, followed by designers. And people in general worked for small companies, followed by being self-employed, and then working within a big company. So we got a really good picture of who our audience was, and they were kind of varied people who were all very product focused. And our big question was kind of, how much do you expect to spend on making a prototype? What we really wanted to understand is that whether you're in a small company or a big company, are you just kind of, you know, putting together quick works like prototypes just to test a function? Or are you really investing in building out high quality prototypes for testing and feedback? And we found that the majority of those who we surveyed were spending either between $200 and $500 or $500 and $1,000 for building prototypes. So we thought that was really interesting. You know, people are investing in building prototypes, and you would imagine that you want to get something high quality out of that. We were also wondering what traits people were looking for in prototyping tools. Of course, we, coming from an e-textile space, want to make things that are drapable, sewable, bondable. We want to make them very e-textile focused. But we started to think in general, you know, e-textiles can integrate into a lot of materials really beautifully. So let's find out all of these different kinds of material traits that people might be looking for across an engineering or design spectrum. And we found that the top trait people are interested in for parts to prototype with are flexible, like a flex PCB. Secondarily, we found that they want them to be easy to solder and make connections with. After that, they'd like them to be stretchable, sewable, heat bondable, additional features. But something that we thought was really interesting was how much flexible mattered to people. And e-textiles by nature are really flexible. They have multi-axis flex actually. And we include that in the question about having the parts be conformable, which people wanted above creasable and heat bondable. But that flexible kind of conformable space we thought could be something to work with. We also wanted to understand, what people were doing in the group that we surveyed. So we asked people what kind of projects they were working on. We didn't give them an other option, so they kind of had to choose one of these, which was a mistake on our end. But we found that there was a high representative of people doing wearable technology projects. And then followed, we tried to get specifics of people with flexible sensors, which could be wearable technology or something else. And then after that, we had soft control services, which tend to be very e-textile focused. So we thought that the feedback from the people who we did the survey with, it seems like they were willing to identify that they were working on something non-standard for electronics. Nobody wrote like control systems. I guess we didn't really give them a control systems box, but in terms of our audience, these were the people who we were really interested in hearing from when it comes to prototyping process. So from there, we reflected on our own challenges with prototyping, making a good looks like prototype. And of course, the hard-soft connection that we always talk about in e-textiles came up, that it's really hard to prototype a good hard-soft connection. We also found that it's really hard to integrate wiring without sewing conductive thread, which we also heard was a process a lot of people wanted to avoid. And then of course, the z-axis height of traditional components can often make for unfinished looking prototypes or mechanically weak prototypes, which is a challenge for any sort of testing or looks like prototype. So with all this information in mind, we started working on creating a product that we thought could be flexible, stickable, have good connection methods, be useful for engineers and designers in the wearable tech or other kind of soft flexible circuit space. And we were careful not to call our product an e-textile because it's actually laminated in TPU. So we got some feedback that it could be called a part to make an e-textile with. You can attach it to a textile and make it an e-textile, but the parts themselves shouldn't be called e-textiles, which is an interesting linguistic revelation for us, just to see how people identify certain materialities with certain words. And the collection we made of these parts that people could use for high fidelity prototyping were buses, pressure sensors, heaters, and user interfaces. So we made this collection of parts, and they all had a special interconnect on the end that allows them to be either breadboarded or soldered bus to bus, part to part. We also made sure that they all had a sticky backing so they could be easily attached to a textile, making them a part for using with wearable technology or a part for using with textiles in general. So we did all of this and we made a marketing webpage and just asked people, what problem does this product solve for you, if any? Because we wanted to make sure that our hypotheses about this idea of, one, it being hard to make a looks like prototype using e-textiles, and two, the idea that the connections and some of the integration were challenging. We wanted to make sure that the product was actually solving those and that people saw those issues too. So we ran a new survey. This one had slightly less people, around 54 people. And we tightened up the categories. So we had mostly creative technologists, followed by engineers, followed by designers. So it's kind of a similar trend of people. And a lot of the comments that we got spoke to the issues that we are seeing, that transitioning from a functional prototype to an implementation prototype to a launch-ready product is really hard. And this kind of product can make that easier. So, this product can be useful for the looks like prototype, which was our goal. Somebody else mentioned that this product was useful for having flexible connectors while also maintaining good aesthetics. So that robust connection was one of our goals. We got feedback, someone said personally, I don't use this stuff a lot, but they could see the value for engineers and creatives to make a proof of concept that could go a long way in design and testing before market. So again, that looks like prototype. And we were thinking, okay, it seems like we're solving the problem that we think is there and other people can identify this too. So from there, we started working with the University of Colorado Boulder in their Unstable Design Lab to do beta testing hands-on. And of course, during COVID, everything was remote. So we sent out a bunch of parts to different designers and engineers to get their feedback on the parts that we were making. And we found the designers were really gravitating towards the heating application. So they were very application focused. they thought heaters can make a good, interesting material for different applications. And that the engineers really gravitated towards the pressure matrix, which can read up to 9 individual analog pressure locations. And they thought that the complexity and the uniqueness of the pressure matrix combined with the materiality of it being made for making e-textiles was really interesting. So we saw a difference of priority between those who were focused on the application and those who were focused on the technology, thinking they might find an application later. So after this beta testing, we continued to give the parts to a big group of creative technologists to work on projects to see if people could actually integrate these into somewhat final looking prototypes. And we found, we gave them to 7 creative technologists total, and these are 3 of the projects that were made. One is a warming band for comfort or for health reasons. The other is a light up backpack that's solar powered, and our parts are used in the straps for control. And the last one is a color changing wall art piece. So, none of these are wearable technology. They tend to be more of like very product focused, but we thought it was interesting to see, can you make something that looks somewhat finalized using these parts, and are they helpful in any way for using these parts? And these are just some images from one of the integrations that one of the creative technologists did. So you can see how the parts are used to integrate the pressure matrix with neoprene. They use one of the buses to fold around the back of the neoprene and have the heater on the other side, but they still do have a lot of wiring in the project. So if we actually want to get out some of the the traditional wiring, then we need to do further development on this product. And you can just sort of see the front and the back of what they did. So they did soldering, they, they stuck the pieces to the neoprene, which is what we expected. So we saw a lot of expected use from these parts, but we also got to see, okay, there's still something to be desired in terms of solving all of the wiring that you might want in an e-textile like product. And this was their integration into the actual sash that you might wear. So anyways, I hope that this has been kind of informative or interesting just to follow along our process in developing a product to use for prototyping e-textile products. And our goal was really to solve some of the challenges with the works like looks like prototype. And from some of the projects that people worked on, we think that we helped to solve some challenges. Of course, we still think there are some challenges that exist for making something that looks really final and complete. So we'll continue to do this work. And if you have any questions, please email me at maddie@lumio.com. I'm always happy to chat. And then of course, our website's listed here as well. All right, thank you so much.
That was an awesome presentation. Our next speaker will be Tamim Molla. Tamim is a postdoctoral research associate at the Hybrid Body Lab at Cornell University. His research interests include wearable technology, e-textiles, textile engineering, additive manufacturing on skin interfaces, and human-computer interaction. He develops novel systems with special focus on soft, flexible, and wearable applications. The topic covered today will be, how do we do this? E-textile products for consumer and medical applications.
Hello, everyone. Can you see my slide?
Yes, we can see it.
Okay, thanks. So hi, everyone. Welcome to my presentation. My name is Emre Tahmid al-Islam Molla, and I'm a postdoctoral researcher at Cornell University. So I have completed my PhD from University of Minnesota. As I mentioned, by profession, I'm a researcher. So I developed novel system with a special focus on flexible and wearable applications. So I did my PhD dissertation on manufacturing of e-textile, where I specifically focused on how we can develop low-cost, flexible, adaptable garment integrated technologies using off-the-shelf tools and machines. So for today's presentation, I have divided my presentation into two different sections. So in the first phase of my presentation, I'll give you an overview on manufacturing of e-textile. And in the second part, I will present a design framework for manufacturing standard e-textile. Okay. So there are a lot of wearables currently available in the market. For instance, we are all familiar with smartwatches such as Apple Watch, fitness tracker, like Fitbit, or even smart glasses. So why do we need e-textile? Currently available wearable devices often lack user comfort and convenience. Since most of the developments in the wearable industry are mostly led by technology developer rather than textile technologists, primary attention has been paid to technological advancement while mostly neglecting user comfort and convenience. So as you can see in the picture, like most of the existing body-on devices are enclosed in a single unit, which restrict the wider distribution of body-on technologies. Components like sensors and actuators, which may benefit from specific on-body placements, are often constrained to fixed physical locations. So integrating electronics into clothing can allow more flexibility on the placement of electronics, reduce the necessity of using a large number of body-on units, and simplify power and networking. And most importantly, it will allow seamless integration of technology into our life. So in some, clothing may provide expanded functionality and comfort for existing wearable devices. So as you can see, there are a lot of benefits of integrating electronics into textile. So why don't you see a lot of e-textile products in the market compared to other traditional consumer products, such as like smartphones or laptops? And that's a valid question. So one main reason is that the lack of standardized manufacturing process of e-textile. So like manufacturing of e-textile is a challenging process. So I'm going to briefly talk about some of the challenges involved in manufacturing of e-textile. So the first issue is the fabrication of circuits on textile substrate. And it's not a very straightforward process. And in fact, it's a very challenging one. The shape and size of the stiff and rough electronics are not often incompatible with soft and flexible textiles. Second, there are differences exist between electronics manufacturing and apparel manufacturing. The electronics manufacturing system is mostly automated, high speed, and reliant on rigid materials. On the other hand, apparel production is almost completely manual, slower, and designed around soft and flexible materials. So the method that work well for apparel might create new challenges for design and development of electronic technologies. Third, there are several limitations of using textile-based components and conductors. There have been a lot of work going on developing new e-textile sensors and actuators, and most of the time they're not comparable with traditional electronics in terms of reliability and accuracy. For instance, electronic traces integrated into fabrics typically have higher resistance compared to traces used in PCBs due to the uneven surfaces and skew shapes of textile conductors. And finally, durability and washability of e-textile is also a major concern. Like since e-textiles are like kind of garments, you wanna actually use them like regular clothing so that you can wear them as many times as you want, and also you should be able to wear them. But components attached in e-textiles are often not able to withstand regular wear and tear, and they cannot be washed using washing machine. So to have a better understanding about these challenges, we need to have a solid understanding on the manufacturing process that are currently used in the e-textile industry. So there are several approaches that are currently used for embedding electronics into textiles. All these approaches can be described into three different categories. The first approach is integration of electronics directly into textiles, such as fibers, yarns, or fabrics. For example, here's a picture of a fabric. You can see like where the conductive copper wire is directly integrated into the fabric structure. So the benefit of integrating electronics directly into textiles is that the electronics are not visible from outside, and they do not change the desert look and feel of the textile. However, the integration of electronics into textile is a challenging process and often require new machines and tools which are not always readily available in the apparel industry. The second approach is attaching prefabricated electronic system onto the surface of the garment, in which electronics are housed in pockets and cables are run through channels in the garment. So for most of the system, electronic systems and garments are manufactured separately, and they are combined at the final stage by some kind of connectors. The main disadvantage here is that since prefabricated electronics tend to be more bulky and stiff, the electronic system will be more easily visible from outside and may not be always convenient for users. The third and final approach is attaching traditional electronic components directly onto the surface of a textile. This kind of hybrid manufacturing process leverages the benefits of electronic industry by using easy to assemble electronics, and the textile industry by using the comfort properties of flexible textiles. So similar to a typical electrical circuit, an e-textile circuit consists of two major segments. There is one rigid area with electrical components and a flexible area with electrical traces where body movement happens. So you can think about this like you have a central processor in some part of the body, and then you have like distributed sensor and actuator on different part of the body. And so these are like the rigid component, and then you need some kind of conductors to connect them together so that they can transfer power and communication. Several techniques are used for electronic component attachment, namely sewing, soldering, welding, crimping, adhesive, etc. Soldering is one of the most common way to solder electronic components into textiles. For conductors, there are different types of conductors used for e-textile as well. Conductive yarns are one of the most common types of conductors used in e-textiles. In addition to that, conductive inks are also suitable for adding conductivity to specific areas of fabric. Often wire connectors are used to create reliable connection, but wires are not as comfortable as compared to like conductive wire or conductive ink. So for garments having a complex electrical system in which a large array of interconnects is controlled by a central processor, it may be necessary for traces to cross in the garment. For instance, here is a picture of a PCB where, as you can see, like different traces are crossing each other. In PCB, like multiple board layers are used to allow traces to pass under and over each other. However, in textile, many layers get cumbersome and inconvenient. So traces can be routed in e-textile using different techniques. So one way is using weaving and knitting. For instance, using weaving, different warp and filling yarns, both conductive and insulating, can be arranged in any desirable order, and each yarn can be individually addressed and manipulated to facilitate interconnects. Another way is like using stitching or printing. So one of the benefits of using stitching and printing is that they allow traces to be placed in almost any orientation and position on a fabric piece, and therefore provide ample flexibility for trace layout. Similar to PCB, there will be some instances in e-textile where traces need to be crossed, and you need some kind of insulation to prevent a short circuit. So for example, here is an example of trace crossing, as you can see, like where different traces cross on top of each other. And then there will be situation as well in garment like seam crossing. So you think that you have component distributed in different part of the body, like you have component on the sleeve and you have component center processor on your body. So you want to make some connection between them on the seam crossing as well. So there are several approaches that can be used to do trace crossing and seam crossing in e-textile. So one of the approach could be using float stitch, where you float one stitch over another. But in that case, you have to insulate the other stitch by some technique so that it doesn't create any short circuit. You can also use like insulated conductive wire, but then in that case, you need to figure out a way to remove the insulation from the specific part of the wire. And another approach would be use multi-layer e-textile circuit. So and that can be done using like adjusting the tension between adjusting the tension in the sewing machine. So for example, one example would be like using a lock stitch machine. As you know, in lock stitch machine, you have like two different threads. One is like needle thread, another is like bobbin thread. So by adjusting the tension, you can make the stitch such a way so that only one side of the fabric will be conductive and the other side will be non-conductive. So the situation where a trace crossing is unavoidable, you can stitch just on the other side of the fabric and bring it back to the right side to make a connection. So for example, here is a picture. As you can see, like the black lines are the conductive traces, and this is the area where like you have some trace crossing. So you just go back to the other side and then stitch it and then make connection here. So in the e-textile industry, three different types of business model exist right now. So the first approach is to follow the business model of the mainstream wearable technology industry, where the garments production and electronics production are made separately, and later they are combined at the final stage. But the problem with this approach is that the garment and electronic system are much more tightly intertwined than simple attachment of a standalone system to a standalone garment, and a more granular integration of the steps needed here. The second approach is to design the manufacturing process with proprietary equipment for a specific product that allows the textile and electronic system to be more tightly intertwined. The disadvantage of this approach is that the manufacturing process will change every time in making a new product. And the third approach utilizes the equipment of the PCB industry and thereby develops a universal manufacturing process for different products. However, to enable this flexibility, the production cost increased significantly for equipment development. Depending on the product and skill set of a company, one approach might be more suitable than the other. So here I'm proposing a design framework for product development process of standard e-textile garments. So from our research, we found that there are 7 major steps that involve in developing standard e-textile garments. So here steps 1 to 5 are the product development steps, and steps 6 and 7 are the production related steps. In the next few slides, I will briefly talk about each step and describe the tasks involved in each step. So the first step is designing and constructing the electronic hardware system. So, so you have to start with the hardware system and you have to come with the design that you want to make. So the electronic hardware system for the garments need to be developed, and which is particularly important because it helps to determine constant in electronic components and system architecture and shows the feasibility of transferring into an e-textile. So it might happen that once you make the hardware system, you realize that there are certain parts that you cannot actually transfer it for e-textile components. And the hardware should contain all the necessary components to make the system work. For example, it should contain the sensor, the actuator, like the microcontroller, and battery, etc. A prototype may be used for quick and easy circuit system development. Once the hardware system is developed, the system firmware and software should also be developed in this stage. So the second step is designing and testing e-textile swatches. So in the previous step, we developed the electronic hardware, and in this stage, we are going to construct it for e-textile circuit. So before making the whole garment, this is the idea where you're going to like see whether the electronic system you develop, you can actually transfer it for e-textile swatches. So in this stage, all the circuit components, such as like the connectors, the components, wires, sensors, that need to be integrated into the you need to integrate into the electronic system can be also transferred to the e-textile swatches. So there are 2 main steps involved in this stage. That are one is selecting and testing an electronic integration methods, and second is selecting materials for e-textile product. So I already described in my previous slide, like there are different ways you can actually integrate electronics into components, such electronic components into textile. For instance, like you can directly integrate them into textile structure, or you can use like off-the-shelf components to integrate them on the fabric surface, or you can actually use prefabricated electronic system. Depending on your system, the manufacturing process will vary a lot. So for example, here is a process you can see like where you design a circuit using a programmable sewing machine, and then you stitch using the sewing machine, and you use a surface mount component and solder them directly into the traces, and then you test the system to make sure the system is working. And this is the stage where you also select all the materials you need. For example, this include like the material you need for making the garments, such as fabric, cheaper, this kind of stuff. Also, you need to select the materials that need for electronic components integration, such as sensors, actuators, etc. So third step is product soft good design. And this step involves 3 different stages. The first one is designing the garment. So this is basically, you are going to design the garment, like how the design will look like in the final stage. And the next one is component placement. So you also have to make this decision about how the components is going to be like distributed on overall the garment. And also you need to find out a way to like routing traces on different components. So for example, here you can see here is a picture of a garment where you have, you can see like different types of sensors are distributed on different parts. So you have sensors on the sleeve, on the front part, on the back part, and then you have a centralized system that connects with all of them. So, and then there are situations where you can see like the traces go one over another. So here, for example, here is an example. So you have to make the plan. You have to ensure that like you have less number of tracing, but there will be situations where you have to like, you'll have trace crossing and seam crossing, and you need to use like the proper technique to do the trace crossing and seam crossing in e-textile. And I already described some of the technique in my previous slide. So The next step is actually fabricating the prototype garment. So these steps involves pattern making and fabric cutting, developing printed circuit board, electronics integration, and garment construction. So basically you take a fabric piece and then cut into like small pieces, and then you start integrating electronics component onto the fabric pieces, and you test them individually. So you make sure that each piece, each panel is working perfectly, and then you sew them together. So then when you're sewing, you also think about the trace crossing, seam crossing, and all these factors variable. And I would like to mention here that it's much more easier to integrate the electronic components when the fabric is in 2D shape compared to when they're in 3D shape. So there are a lot of things that you cannot do when you actually sew them together. So you also have to think about like the pros and cons and what should be the steps look like in your e-textile manufacturing process. And the step 5 is the quality test of the product garment. So in this state, like both the quality of the garment and also the electronic system need to be tested. You also need to perform troubleshooting and rework if needed. So this quality testing of the finished e-textile product is also challenging stuff. And there are a lot of things that need to be done on this area. Because like when you actually make the prototype, if there is any problem, then it will be difficult to fix the problem. And there is a chance that you can always ruin the whole garment when you're actually trying to fix the prototype. So it's much easier if you can look into, you can do like multiple testing when you're actually making them, joining them together, and then ensure that in the final product is you have actually final functional prototype. So once you have a prototype, the next step is to develop e-textile garments in bulk. So to produce garments in bulk, a production planning is needed to ensure a smooth and uninterrupted production. So here I have listed some of the steps involved in production planning. All these steps are very common in traditional apparel manufacturing, but you have to modify them for e-textile. So for example, like market development, we know that in apparel industry, we typically use market to cut fabric pieces in bulk. So we have to do that for e-textile as well. However, for e-textile, we also need to think about like, how can we actually use different darts or marking points to like, to locate the position of the sensor in the final garment. We also have to use a tech pack. So a tech pack basically contains all the necessary information to produce a certain style. And it contains like the color, style, number of quantity you want to produce. So for e-textile, you're going to have the same thing, but for e-textile, you're going to include information about like electronics material as well. So in addition, you also need like machines and tools for production, which is mostly depending on your manufacturing process, but it can be also modified based on your existing facilities. And then you have to also have a production workflow for the e-textile. For example, on my right, I have a production workflow here. As you can see, here is input and output. So here the blue boxes denotes like the regular apparel manufacturing process, and the green boxes denotes like the electronics integration process. As you can see here, the electronics integration has been shown as an integral part of the process rather than a separate process. And finally, you have to do a quality assessment of the final production as well. So for the final production, so this is the final step. So where you're going to actually manufacture e-textile in bulk. Depending on the expertise and facilities of the company, the production process could be divided into several sections, similar to like a typical apparel production system. So you can have like one section they are doing the cutting part. There will be one section when they're going to assemble or integrating the electronics into fabric. There'll be one section who is going to do sewing all the garments, all the pieces together. And there'll be one section who is going to do apart from like testing of the final garments. So in summary, here are the list of things that I think companies should consider when manufacturing e-textile. First, they need to determine electronic component. So this includes like the package size, the type, the connectors, and insulation material. Next, they also need to determine the integration method for system components, conductors, and trace crossing and seam crossing. They need to design the garment sensor circuit, trace layout, etc. And also they need to develop a method for performance and quality testing of the product. They need to identify tools and machines. These are particularly necessary for that particular, to manufacture that particular e-textile product. And finally, they need to determine operation sequence, because certain operations should be performed before the another one. So yeah, that's all of my presentation. Thank you for listening. Yeah, feel free to reach out to me if you have any questions or wants to know more about the research. Thank you.
Thank you. I appreciate your time. That was some very interesting concepts raised. I appreciate it. Our last speaker for the morning section is Paul Wagner, Chairman and CEO of Minnesota Wire. Paul became president of Minnesota Wire in 1992 and was named CEO in 2000, where he greatly expanded its market exposure, including the medical, defense, aerospace, and commercial sectors. The company won a prestigious TIBIX Award in 2007 for excellence in small business innovation research, and recently, Paul was awarded the 2020 Wire and Cable Manufacturers Alliance Distinguished Career Award. The topic for today is medical trends in e-textiles and the development of smart wearable patient monitoring devices for COVID-19. Paul, whenever you're ready.
How's my audio? Sounds good. Thank you. I really do appreciate some of the time here. IPC Textiles has been a good format for us, and wish you the best. Special call out for Chris and Meg Grant and Lucy Dunn have been good colleagues for years, and nice to see them participating. In summary, and you can go first slide, please. Minnesota Wire is a 53-year-old family business. We're a bit of control freaks and unusual in the same sense. We design work, so heavy engineering. We also extrude 140 million feet a year of wire. We also wrap and sinter and braid, and we even do some other things. But then we cut steel. So we've got machine shops. We've got 25 molding presses. And then, of course, cleaning, bagging, and testing and validation processes. So we're primarily 70% medical, 25% aerospace and defense, and 5% R&D. It's a little bit of our makeup. Now, the factory on the left-hand side in St. Paul that I'm located presently, it's a little under 30,000 square feet. And basically, it's all the creatives. It's all the interesting things. What did you learn today, et cetera. So now we do have 4 labs. So we've got EMI, RFI, low loss. So we're shielding experts. We also do flex testing, impact testing, torsional testing, moisture, et cetera. On the your right, Eau Claire, that's really about cost. 2 shifts, hardworking, guys and gals, passionate people about what they do, and but it's really designed around all the documentation, all the hassles, all the customer contacts are done here in Wisconsin. They just want to get it out the door, and so that's the difference. Next slide, please. Thank you, Chris. Overseas manufacturing challenges and trends. I started traveling Indonesia, Malaysia, Thailand, China, Singapore about 20 years ago. So I've seen a lot of change going on over the years, and certainly it's changing fast right now. So it's an interesting trend on the reshoring, bringing things back from China. And we believe we've had 6 different customers where we develop things, and it's quite labor intensive. So the desire is to go overseas and reduce costs, and we understand that. But at the same time, we're seeing 6 customers come back from Asia that haven't been with us for maybe 15, 20 years. So that's an interesting trend. Now, when I looked around at some data, I recall when China passed Japan in their gross domestic product. You know, and so we're sitting here at 20 trillion in the United States. China's 13 and Japan is 5. So 10 years ago, China passed Japan, which means they've grown by $8 trillion in 10 years. Well, that's pretty impressive. And you've got, and they're now obviously selling to their own citizenry rather than just exporting, similar to India with 1 billion people. Well, okay, so now if anybody has not traveled there and you're trying to do outsourcing there, it really, really behooves you to go there and get a relationship. And I settled into Korea. Out of our $22 million a year, we take about $1 million out of Korea, but it's a really rock solid relationship. So that's well, and some of the other issues on China is that, well, obviously it started with the tariffs, you know, so that shook the whole tree up. And then the big guys are moving, you know, they've got 80-20 China, maybe Vietnam. Well, now it's shifting. Well, the mid-sized companies are frankly leaving in droves. It's quite a trend going on right now. And the smaller players are, like myself, are really getting kind of lost in the shuffle. So a lot of change going on. You know, you can find any price over in China. If you look hard, you can get whatever you want. However, it comes with baggage. There's a lot of really pristine, beautiful factories over there. There's also some old school ones that are still look like they're 50 years old, and they haven't changed in 50 years. Let's see, the pollution concerns. I've seen a lot of nasty things. So you got to be expecting that if you're going to go over and take a hard look. The 5G piece, you know, and some of that, I don't know how folks really track and trend that, but that started the wave of looking at the intellectual property being stolen and such. There's a couple different ways that are oftentimes done so that can give you clues. One is, obviously, all the factories are owned by the government. So they can come in and pressure those guys to add a chip or add some code. And frankly, you never know it. And that's one of the easiest ways to harvest software code, et cetera, your boards. The other is that they'll hold things at the border, and it just goes into a bucket of, you know, it's getting through their bureaucracy. Well, what they're doing is they're reverse engineering the materials and or adding components and parts, and you don't know it. So that's a kind of a red flag. If you ever have a big delay, typically 2-3 weeks extra, something goes up. And so anyhow, the medical manufacturing, as I'm heavy into that. So there's added concern, and COVID, you know, starting obviously in about March, started to bring up these issues. Well, certainly the drug raw materials and such, you know, raise the big red flag. And so on the medical side, we see the trending coming back to the States, which is good for jobs and I think good for America as well. Similarly, we've been dealing with the defense industry on the components and parts. In that case, you can make up partials over there and then bring them to the United States with a 49% content. And then 51% has to be added value into the United States. Well, that's a blurry line sometimes, but it's getting a lot more scrutiny now. So there's a trend there. So any regards, the remote patient monitoring, we started making cables that stretch many years ago, I'd say 10 years ago, for the communication systems. So we started making conductors and such, that stretch. There we go. Sorry, got a little delay here. Well, I'm going to show you some of these. So these stretch back and forth. These are conductors. And then we in the textiles, some are extruded, but some are just pure textiles with electrical components. So this would be another one. Thank you. So that's a 4-conductor IMU type cable. Then that started into putting them into remote patient monitoring systems. Grandma gets a new knee, and all of a sudden you're doing you're supposed to do your 30 leg extensions 3 times a day. So now there's devices that stretch, you put it on, it's got little LEDs as well as a communication system, starts chatting with you, time for therapy, wakes you up, and then you put it on, you do your stretches, and it audits that. Now, a uniqueness there is that some of our customers are actually paying the patients directly, not through the insurance, but giving them a check for $500. If they'll wear braces like this for 30 days and stay on track, the patient outcome is much better. This is an exciting move for us, and paying attention to e-textiles and wearable electronics, because it is a big move in the right direction. Now, some of these others are like a basketball body positioning. You get 1,000 data points per second, with a basketball shot. This is in the NBA, it's NCAA, et cetera, but that maturity is growing in leaps and bounds. So we're having some really good luck. Let's see, some of the what we call the puck or the computer and the battery, they snap into components, and then we put in wiring these right into the e-textile units. Shirts and sleeves and trousers and all sorts of other things, but usually about body positioning for the training. However, I see where the real growth is in remote monitoring. That the rural healthcare is really being excellently served when grandma can put a t-shirt on and check her heart and say, no, you don't have to come into the hospital. We'll see you on Tuesday. Those kind of components and parts are really growing fast. So I've got the rural healthcare specifically, that have distance into it. Now, we've also been starting to train anybody that's participating in with doctors these days. They're doing virtuals just like this, and that's not going to stop. They get fresh data. It's really a disruptive technology. Well, the other thing I want to remind people of on the medical side, we get a lot of entrepreneurs that come in here. They give us 10, 20,000 bucks. We make widgets and prototypes, but some don't look at the Affordable Care Act changes. Those are still coming. Even in January 1st, there was new changes that came about, and that's 7 years later. Now, particularly to the reimbursements. Now, if you design a great widget, however, the reimbursement schedule is low for it, it's not likely to get pulled through commercialization. You have to be in step with those designs. Also in step with what's been approved, by Medicare. Because if you design a widget that's 6,000 bucks and, it's only got a reimbursement of, say, 600, well, guess what? You're not going to sell anything. Okay, so those are some lessons learned that I've got. And next slide, please. The integrated circuits. Well, as I mentioned, we're making all sorts of things that stretch and bounce, connectorization, for it. There we go. Okay, so however, about maybe 10 years ago, lots of companies came to me and said, hey, I want the components and the parts woven right into the clothing, and I'll take out a little puck of sorts, but at the same time, the secret was to get the integrated MEMS component inside the wire. So that's what you're seeing here on the screen. So these parts are stretchable, of course. However, inside of them, there's a MEMS right there. I can feel it. You can barely see it. So we've got, we started with thermistors. Then we got accelerometers for body positioning. Gyros was next. And we're working on SpO2 right now. Emitters detectors are a little difficult. You get a good you get the heart rate with it, but oxygen is a very serious opportunity. So we want to get EKG, biofeedback, muscle, temperature, drug delivery systems, but all inside something that'll last a washing machine. We are experts at termination, so sealing the back end of connectors, and that's part of our future. It's got to be simple, it's got to be intuitive, and it's got to be accurate. Are all really important design criteria in order to get it to be pulled in. And 10 years ago, we couldn't do this because the MEMS chips and components were so large. Well, the phones have created all these relationships where one chip is now doing 4 different things. And so it bred this opportunity that they miniaturized it. With that, we could finally put it inside a wire, that's the size of probably 60 thousandths of an inch. Okay. The last point is your code, your software. And again, now that we got phones, everybody's got a computer with them. And so obviously it makes good sense just to design an app and run with that. And you got to focus on the hardware or, the shirts or the other components. So that's great news. And I would urge folks doing the design, that they take full control, even if they're a component manufacturer like myself, to do the code. The code gives you so much more interesting education, et cetera, on what these things are doing live. And you're not reliant on somebody else to make it intuitive, easy to use, et cetera. So that is my presentation. Many thanks for your time and interest. I'm having a lot of fun with this industry. And quite frankly, I know we're saving lives and we're improving healthcare for Americans, well, other people around the world, but particularly people in the rural areas that don't get the best of care. Okay. Thank you, Chris. Appreciate you doing the slides.
Okay, thank you. I want to thank all our presenters for their time and their information. We're ready to open the Q&A section. So if anyone has any questions, you can either, should they speak up or should they put it in the chat?
So I would say, please speak up. So just kind of call your name out, and then, oh, it looks like we have a couple of questions coming in. If you see the hand up, it looks like it's working for people. Erica, so let's take the first one from Pratyush Rai. And everybody, if you want to turn your cameras on, please feel free to do so.
Yeah, thanks, Chris. And thank you, Paul. That was a good presentation from Minnesota Wires. The product, the flexible wire with electronics embedded in it was, that's an amazing prototype. Brings to mind a lot of other things which people are doing. So the key question is, with all the functionality which is incorporated into the thread or into the wire. How do you envision it getting integrated into a wearable textile-based form factor? When do you think of it to be, is it something which can be stitched in, or it has to be integrated through piping or any other methodology?
We do make ribbonized materials. So we will take the eye stretch of this nature, and then we'll actually weave a braid around it, and then so you can stitch it back and forth. So it's almost like an underwear feel and such, but it makes it much more easier to adapt to the clothing. I know some others are actually putting it in the piping, you know, and replacing the spools that they have, you know, just with things that look like the piping and act like it. But, you know, I think a key there is to design it for their capital equipment so they don't have to do any extra work. Make it easy for the next guy.
It kind of brings to mind the project which was run by Google. It was called Project Jacquard. They had a thick wire like this, which was put into a Jacquard machine. So yeah, this is an exciting product. And how do you make connections? Like, is there a proposed methodology for making connections with your wire and electronics?
Well, the ones that have the integrated circuits inside the wire, there's a flex circuit inside there. So you have to design the flex to do the termination. But the real key is to seal it, you know, so you can throw it in a washing machine. And that's important. Now we're sealant experts, and we've got capital equipment to take it down to 9 meters. I'm sorry, 3 meters, 9 feet. And so there's many new technologies in potting materials, soft urethanes, but they seal beautifully. And, you know, so we've been asked to do that for many, many years. So we've got a long history of sealing things. Still, the body contact being worn down via the carbon or via the silver, you know, plated materials, you know, that's a key to longer term washing machines.
Yeah, that's encouraging, because a lot of times to integrate the go-to material, like we heard in previous presentations, was to use silver-coated nylon or carbon fiber. So, but that makes for a very big footprint for actually making contact between the microchipsets. Like, let's say you want to put a men's microphone on your garment. So yeah, I would be, just to sidebar it with you at some point of time, maybe during the discussion sessions, I would be happy to, I'd like to know more about that product. Thank you so much.
If anybody would like a sample too, it's always fun to touch it and feel it. And we do have kits. So just send an email and I'll pick up the phone and holler at you. And my cell phone's always on.
Thank you, Paul.
Sure.
Are there any more questions? Anyone else has questions?
I've got one more question for Paul that plays off of the previous discussion. This is Damon Brink from ACI Materials. Paul, when you're integrating that into a full e-textile, how do you handle going across seams? Do you integrate that on on a full garment, or is it just on one component?
You know, I'm not the garment manufacturer, and in the military, we usually use a TRL, or technical readiness level, you know, and I'm selling probably 40 different customers, different varieties of these products. But this one's really at about a 5. We make it work. It's been prototyped. It functions. At the same time, it's not ready for commercialization. You know, we qualified for deep space to go to Mars with some of our products. And we understand the discipline of what real validation is. And I'm just saying this functions, but these we make hundreds of thousands of feet of. I'm sorry, I didn't really, we don't make the garments.
Sure.
We make components for them. I know that in some cases, as far as cross goes, they just go up and over. It doesn't, you know, it's all, some of these are conductive, but usually they're coated, you know, with a very thin material. So you would barely even notice that it's got a coating on it.
Thank you.
Sorry.
Any other questions?
Like we have a question from Vignesh.
Yeah, hi. Actually, it's for you, Fahim. Just real quick, awesome presentation, everyone. Paul too. I loved all of it. A real quick question. I just wanted to know, in terms of medical products, are there any particular design decisions people take in terms of skin adhesion? Because there's been a lot of movement in terms of capacitive ECG and non-contact sensing methods. Do you think we can adopt some of those techniques to reduce the, to make it more integratable in the field without undergoing the full contact validation? Just wondering if we have any thing to share on that.
The best tip that I could give you is pay close attention to the physical therapy industry. I think 2 years ago, January 1st, the FDA changed the rules. You no longer have to do a 510K to launch a product into that. So body positioning and rural healthcare that can be made in a disposable, you know, this is a 30-day device. It's much faster to get to market and much faster to get to revenue.
I see. Would that also include the connectivity hardware, or would you frame it more as like a replacement? So razors and blades model. So where the control electronics would be reusable, but we send them new electrodes or new textile embroidery parts.
Well, on these disposables, it's sells for about $500. It's a one-time deal. They have some HIPAA issues, so they're sorting through the confidentiality because you're going through Bluetooth. But the phones are shifting everything. I'm not sure I fully understood your question, sir.
Sorry, Paul. I just meant, do you in your designs reuse the electronics part and instead just ship them the sensing unit? I'm just wondering, I mean, is there any potential for using the electronics in multiple sensor patches over time?
Well, certainly when we design something, we want to sell more of it. And we typically own the design. So we're motivated to solve somebody's problem, but solve an industry's problem at the same time. Now, we have code and software and we can make the whole device, but frankly, most of the time we're selling components and parts.
I see. Thank you.
Good luck.
Does someone have a question? All right, I have a question for Tamid. In your topic, can we develop e-textiles in a traditional apparel factory?
Yes, sure. Thank you for your question. So the way I presented my presentation is that I was looking at more from from apparel manufacturer perspective. So I was trying to say that like you can use like existing tools and machines to produce like e-textile in mass. So for example, like we do have the apparel production setup, right? We do have the sewing machine. We do have like more like automatic machine right now. We have the programmable machine. So we can actually make circuit using maybe, let's say, using like a circuit software like Eagle or something, and then you can transfer them to like a programmable sewing machine or even embroidery machine, right? And then you can stitch them directly on the fabric pieces. So in my PhD project, I try to actually develop a whole trace layout using a sewing machine. You know, so because I try to put components in different part. I showed it in one of my slides as well. Like I put components in different part, like on sleeve, on the back, and then I have the body of like, let's say 54 inch. And then you design the whole trace layout using a sewing machine. So it did the whole thing with the sewing machine, and then you use some kind of like more scalable machine. Like instead of heat iron, we use like a t-shirt press to like solder components into the textile. And all these equipments on the machines that already exist in the industry. I mean, definitely you can like use more modern and sophisticated machine. You can definitely improve some of the manufacturing process, but you can still use the existing tools and machine. Then you can use them to like develop like more advanced e-textile. So I think that, yeah, the answer is yes. You can use like traditional tools and machines that are used in apparel industry and use that as a base platform, and then adapt some of the machines out there from electronics industry and try to incorporate them and then make e-textile.
Okay, thank you. Got a follow up along that same line. What's the impact of technology integration into garment in terms of the labor, the equipment, and the costs to manufacture e-textile compared to, say, a standard garment?
Yeah, sure. So like, so you asked about like what is the impact of like the integration of technology in terms of equipment. So in terms of equipment, like as I mentioned in my previous question, that you can use like traditional machines, and then depending on like how sophisticated you want to make your component or how sophisticated you want to make your manufacturing process, you can have like always more advanced and sophisticated machines. And then the cost is also like, since you are integrating electronics, so there is textile and there is electronics. So the electronic component itself are very cheap, but when you like involve people to work on that, then there is more cost involved. Like there is a cost for the component, there is a cost for like the labor. Since the technology itself is very new, like, you know, it's still in the very like the beginning phase. It's not very sophisticated like electronic manufacturing. So even the prototyping takes a lot of time. So if it takes a lot of time and it's a lot of the process involved, like manual involvement, like you need manual labor. So the cost is relatively high. And then you like more skilled people. So for example, if you think about electronics, like you need people who knows electronics. If you make apparel, you need people who knows about apparel. But when you're talking about e-textile, you need people who have a background in or knowledge in both these fields. So you need like more skilled people to make those things. And also the people who work in the apparel industry, they don't know about like, you know, the circuit diagram. Like you have the conductor in between, but in general, they're just sewing different traces, but like sewing or like making seam line, but there are certain seam line that they cannot touch with each other, you know, so there are some limitation there as well. So we actually we did a study for that one as well, try to understand like what is the actual impact of like the impact of technology into clothing. So we wanted to quantify the value. So we saw that like it took around like almost 3 times higher to in terms of cost, and around 3 times higher in terms of time to produce one e-textile garment compared to like one regular garment.
Okay, all right, thank you.
Yeah.
Do we have any other questions for anyone?
So Corey Lord had his hand up, and then Meg Grant would go next.
Okay.
Hey. I guess I could open this question up to anyone. It's more a materials question. So for a lot of e-textile applications, emulating a wire with a thread is just kind of like a binary operation. It's connected or it's not. But for some applications like wireless charging and RF communication, the properties of the wire matter. So given the requirements for durability for washing cycles and things like that, is there a preferred material used for the conductive thread for higher frequency applications?
I'll give it a quick shot. If you look hard, LITZ, LITZ wire. We sell probably a million feet into the hearing aid industry, believe it or not, just little by the inch. But they use a thin polynylonese on each of the conductors. And they're basically putting 7 conductors together. Also, they're silver plated. Also, they're typically old school. They used to be beryllium, chromium, and I forget what else. Now they've got a RoHS approved, and they won't share their recipes, but they're extremely strong and they're extremely conductive, but yet very, very thin and small. You know, that's what this is. with that four conductor. And the idea of strength comes from the textile. We use a lot of Kevlar and a lot of Nomex. And so you can actually put that inside the material so that as it stops, it'll get a, this will go something like 60 pounds. And you can make it much more, it just gets more expensive. Did that help?
Yeah, that helped a lot, thanks.
Okay.
And I think Meg had a question.
Yeah, thanks. I had a question for Maddie. Maddie, your components look really useful for prototyping and making robust, testable, works like prototypes. But I'm wondering if they also have a role further along the line in integrating them into actual products. Is there a role there for them?
Thanks for asking me. I would hope that there could be. I think that these parts, at least where they are now, especially because we've been developing them largely over the summer, are at a place where we've tested them enough for robustness and reliability to go into a consumer product. But I think that over time, if we're able to run all the proper tests and see that somebody can reliably make those connections and reliably integrate, and the electronics are, continuing to perform well, then maybe it could. And having a modular way of making products in this space, especially small volume products, I think could be really useful. So my answer is maybe, and we'll keep looking into it. But thanks for asking.
Great, thanks.
Are there any other questions? Anyone else's hands up? I can't see. I got another question for you, Maddie. Are there applications outside of wearables for e-textile prototyping tools?
I think that there definitely are. I mean, especially for our business, I think we've seen that our method of doing e-textiles is good for some products and not so good for others. What Paul has at Minnesota Wire, I think it's probably better than our 4-wire bus when it comes to making a really streamlined medical device that you could put in a garment, for example. But I think that a lot of the applications where our technology can be a good fit are in places like automotive or soft robotics or other places where you might need a really soft, flexible circuit to do a function. And a lot of the projects that we got from some of the creative technologists we worked with actually weren't garments at all. So we had some kind of like graph design architectural projects. We had some accessory projects. We had a yogurt fermenting project, which I guess is almost a consumer electronic, maybe. So I think that that's where e-textiles can really find an opportunity, is seeing all that we can do outside of, I mean, there's a lot in wearables, but I think that there's a lot even beyond that.
Any other questions for anyone?
Oh, I have a question, perhaps for Paul regarding medical. I wonder if Paul could talk a little bit about the FDA requirements that his company has to deal with. I know it's a huge topic, but just maybe some gotchas for people who aren't used to working with medical devices and FDA, if he could talk a little bit about that.
Well, again, we have an engineering staff that actually sells engineering details and services and validation. When we set up a flex tester, we'll set up with maybe 3 different durometers of plastic, 65, 73, and 85, and we'll test it. And you can launch a terrible product into the marketplace, but you have to leave a trail on everything you do. And you have to have a justification as to why did you pick that plastic versus this plastic, et cetera, et cetera, et cetera. And of course, there's teams that do this. We don't sell directly into the marketplace. So we're a component and we're at their beck and call. You know, we've got guys that'll come in here and take up our flex testers for a week, and we break things on purpose. You know, we snap things, we literally destroy things. One other thing we do is triboelectric effect. And your chips and your MEMS are now looking so deep into the body, especially with oxygenation and such, and your EKG, a lot of the operating table. Shielding is becoming a much greater issue, protected from the outside. We produce electromagnetic pulse protection for Air Force One. So that's an extreme example. At the other side, anything that moves, it builds up static, and that static creates a poor signal or poor diagnosis on the body. And so you got to protect both sides. But when we're doing wearables, you know, everything moves. So you really have to be very mindful as to how to test for that triboelectric effect and reduce it with carbon-based materials, typically extruded. I'm just distance from those big guys that, you know, take 4 years to launch, and we certainly work with a lot of smaller companies, and the biggest guy in the market is right down the block here. He's about, you know, 5 miles away. So it's a lot of variation. But I'm distant from the FDA regulatory requirements, other than what they send down on the prints and say, I got to have these tests completed. We then do that and we charge for that service.
Okay, so your customers take the lead and the responsibility on that because they're essentially their end responsible. Okay,
Yes,
great. That's really interesting. Thanks.
I got a question for you, Paul, if no one else
Yes,
has their hand up. I think you briefly mentioned that the textile wearable market trends are in rural areas. What are the trends you see in this area?
Well, outside of the medical, body positioning. That's probably 40% of our customers. You know, like I mentioned, this basketball shooting sleeve, you know, just so these guys can test themselves. And they're full of gyros and accelerometers. Some chat a little bit, some give a little lights. But, you know, think of a catcher framing a pitch and making a ball into a strike. I mean, they're getting so detailed of all of that. So I think there's a huge growth on just where's your body and what's it doing for training purposes. It's like a Fitbit on steroids for high-end athletes primarily. I've got one more for you, Erica. I got a good friend that is the #1 producer of weightlifting equipment. He sits on my board of directors, and he owned the Lifetime Fitness, et cetera, et cetera. Now, guess what happened when COVID, you know, it just stopped. Okay, all of his revenue, and he's about a $35 million company, and he had to flip it into home healthcare. And with it came body positioning sensors, you know, to make sure you're doing all the exercise, you know, properly. They're eliminating the trainers, at least they're trying to. And that's creating a whole nother wearable marketplace that we weren't really thinking about. And that's all COVID.
We have questions now from Ona and Corey Lord again. So I think we have Ona go first, then we'll have Corey go next.
Hello, this is Ona from day2. I had a question to Tamilo about manufacturing. Like, what's your experience when it comes to integrating components with lamination or different welding techniques like ultrasonic or RF or just heat welding or things like that?
So are you asking about what is my experience? Like what I think about all this technology?
Yes.
So in my personal experience, I actually haven't explored that area significantly. So I've been mostly working with the soldering stuff. So I can talk about that, but I can see like there are a lot of people working on the ultrasonic welding and all these areas. So I think it's just depending on like, for each method and technique, what I notice in my personal life, there are some pros and cons related with this. In my case, I noticed like all the things I was making, I was trying to like integrate electronics into clothing and try to make sure they're enough durable. So I found that in the case, like the soldering was like more the base technique, but I didn't actually explore the other techniques. So I think I shouldn't make any comments on them, but I see there are a lot of opportunities. Yeah.
Yeah, I was asking, I think lamination is one thing that we in my company work a lot with. And I think we've kind of found it to be working well with e-textiles because you get kind of really smooth and flat surfaces, and the seams can be very flat, so that adds comfort, and like you have a lot of components, so kind of have that like advantage there too, to just have a thin adhesive film or just 2 layers welded together. Thank you.
Yeah, I mean, yeah, that's really makes sense. Yeah, thanks for your question.
A quick comment there. If you Google rotational sonic welding, there's quite a maturity in that marketplace, and it's fed through just like a regular fabric, and it's very quick. Rotational welding, with rotational sonic welding.
Okay, thanks. I'll look into that.
And who had another question? I forgot who else had a question.
That was Corey Lord.
Yep.
Oh, okay, Corey.
Hey, I have a question for Madison. I actually help startup companies with prototyping, and I've talked to quite a few people who have attempted to make prototypes for e-textiles, and it's easy enough when you're talking about making it work on a board, but integrating it into the actual apparel is very challenging. So a lot of people get fatigued, and they might even reroute and try and make a wearable or some other easier technology. Are you aware of any like turnkey like firms or companies that assist people to go from a onboard prototype to an actual piece of apparel? And if you aren't aware of any, do you think that that's going to be a growing market in the coming years?
Yeah, that's a really good point. I've seen that as well, where it's like the wearable idea is just so hard to actually implement that it like the e-textile garment-based wearable is so hard to implement that eventually just gets switched to a hardware device at some point. We do some of that work for our customers, so everything from the software development to the circuit development to get everything fully integrated into something you can wear and test. There are other groups who do it as well too. I don't want to say anything wrong, but I think that Propel does similar kinds of services, but they do a lot of government contracts, but I think they will do commercialized things as well. If anybody's here from Propel, you can correct me. And then also, I think like Myant does that as well. They probably mostly want much bigger customers. But yeah, I think it's a specialty that's developing because as we had heard from Tamadul, it's like you really have to understand both a little bit to make this work. And so you almost have to build a specialized team who can do it. I think it's very hard for somebody, even the most talented engineers, to come from outside and just get it on the first try, how to get electronics and textiles to work well together in a prototyping situation. So yeah, thanks for sharing your experience. It's really interesting.
There was a question from Bijal Patwa. Bijal, did you want to ask your question, or would you like me to ask on your behalf? Okay, so Bijal said he has a similar question. This is about a process to integrate, which is flexible but mechanically strong. Which process is best to use and could be scalable later that doesn't wear out after many washes? I think that one was for you, Maddie.
Of course. Yeah, I think it might also relate a little bit to what Hamadul was answering as well about Ona's question. But we use mostly heat lamination or we use sewing, and both heat lamination and sewing are traditionally used in the apparel industry, so they're meant to endure wash kind of by nature. And we find that that tends to be both strong and reliable. The interesting thing about heat lamination is that the softest materials that we found, which generally tends to be TPU, at least for us, does have a melting point that can be right on the right on the cusp for some automotive applications. So for, I think, like garment-based wearables, generally they don't have a heat threshold they have to pass, but it can just be something to keep in mind during later processing, that you're now adding in a generally lower, like a lower melting point than the textile itself when you laminate something onto it, just from what we've seen. How about you, Amadul? Have you seen anything like that?
I mean, I agree with you, but as I mentioned earlier, that I haven't tried the heat elimination, but we actually did a lot of testing with the washability and the durability of the component. So as you mentioned, sewing is definitely one of the common technique that used in e-textile, and that's definitely durable, particularly durable. And then soldering, soldering is also used commonly in e-textile. So in our case, like what we try to do is that we took one of the common techniques that are already used in the industry, like sewing and soldering, and then try to improve the process. Like how can we make a process that works for e-textile, like not in general for like electronics, because you also have to need to consider different variables. For example, if you want to solder components directly onto fabric, like the fabric has fabrics are more heat sensitive compared to like electronics, like so, but also you need to go to a certain temperature to solder directly onto fabric pieces. So you want to make sure that you don't burn the fabric, but also you want to make sure that you get the desired the connection with the component. So from my personal experience, so we developed a method where we, as I also mentioned earlier, that we solder components directly into fabric, but we use a heat press instead of heat gun. So the benefit we saw on that one is that when you're using a heat press, like it's basically pressing the component directly onto the traces, right? The contact threads. So it's putting both pressure and also it making sure the components are stabilized on the surface. And also, so we saw that it provided a solid connection. And in our case, we provide a washability test, like we put them into a washing machine or dryer, like we left them for like 18 hours. We try to see like what happens with the electronics and the component. We saw like the failure rate is like around 2 to 3%. So which was, and also another thing you can try is that you can use different insulation material. Like right now, silicone is one of the most common insulation material that are used, but also silicone are not that comfortable. That's what I found when actually testing with the user. But there are other like soft material, the fabric-based insulation material that you can try. So we also explored that area as well. So we tried with silicone with like basic LEDs, and we tested with hundreds of samples. We found almost 0 failures with silicone. But then that was a very binary thing, like pass or fail. But if you want to try with more complicated component, then it might also get a little messy. So you need to have a like more more durable or solid connection. So yeah, so that's my personal experience. I would say sewing and soldering is probably the most reliable for now, but there are other techniques that I haven't explored. Yeah.
Okay,
thank you.
There's a couple of questions in the chat. Claire, did you want to ask your question, or you want me to read it?
Well, it's not really a question. I'm just following up from Corey's question and Madison's response, because Maddie definitely called us out. Yeah, we are a small business based in Pawtucket, Rhode Island, and we've had a series of Defense Department contracts working on e-textiles. And I really enjoy these kinds of conversations because everybody is trying to solve the same problem, but from different approaches. And our overall view is that we've been trying to create new tools to add to the toolbox that could interact with any of these things that you're talking about. So we're not seeing ourselves as necessarily the total solution provider, but the thought process for how to put those together. And we've developed some specific solder-free connection methods. We're using a lot of 3D knitting. We can knit the circuit into the textile. We've done specialized heart rate sensors. That doesn't mean to say we wouldn't use other off-the-shelf sensors or collaborate with others on other sensors as well. And having done these DoD contracts, we've got kind of this toolkit, and we're starting to do work with commercial companies that might come to us and say, could you do this? And sometimes we may not be the right way to do it, but we can direct them where to go, or we can collaborate with someone else on solving the problem. So I'm really enjoying this discussion this morning because I've got new ideas from this and new thoughts as well. And I'm hoping that everybody else is too.
Thank you. I think another question in the chat is from Mariana. It's for you, Tamud. How do you address certification concerns during prototyping?
Sorry, is this question for me?
It was, but if anyone else wants to jump in, for sure. But it's how do you address certification concerns during prototyping? So maybe Maddie, you can maybe share some experience as well.
Yeah, I would be happy to. So I guess on the certification side, I also feel like Paul might have, he works in higher intensity certifications than we do, so he probably has some better insight. But if something will be sold in Europe, it needs CE. If it'll be sold here, it generally needs FCC. I mean, you want some sort of UL battery certification for safety. Those are kind of the most obvious, easiest things to figure out. And then it comes down not just to certification, but also for testing for each industry. So each industry has its own needs, and it's understanding the specs there and then running generally third-party lab tests to make sure that you're meeting their spec so that they can then continue the certification to take something to market. So I think that's one of the hardest challenges with making an electronic product and bringing it to market for a small business is that you're looking at a lot of money in certification fees and testing fees a lot of the time. And if that's not done, it can't be sold. So I would say if you have funds for it, then you can generally get those tests done by an external lab. Paul, what were you about to say?
My ad, thank you, Maddie, is that leave a trail on everything. You go to MilSpecs or AES, these societies oftentimes publish, these specifications. You can cut and paste, but just leave a trail on everything that you're doing. If you got a good file, you're protected, and it's good habit.
Let's see, another question in the chat. On the current, I guess it's open to everyone, on the current challenges in regards to finding the right polymetric materials. Can you guys discuss what you're up against?
I can comment on some of the materials that we've chosen and then pass the microphone. So I think when it comes to this industry, as Tamadou was saying in the user testing, people have very specific feelings about how things feel. And so even if the material is the best technically, if it doesn't feel good, people will decide that it's a bad choice. So it's always kind of a balance between materiality and technical specifications. And we've found that generally people are used to things like TPU against their body. Anything crunchy they don't tend to like. So you have to look for low noise, like high drapability kind of polymeric films. Things like curing materials like silicones can also be challenging. So yeah, it's no longer just a technical feat. It's also very much how people feel about it. What were you going to say, Paul?
I was just going to say that our favorite polymer compounding house is RTP. They're based out of Winona, Minnesota, but they've got plants in Brazil, India, about a $400 million company, but they do small batches of carbon-based materials.
All right. Again, if you have questions, you can put them in the chat. I'll be happy to read them off for you, or you can ask live. And I can't see, for some reason, I can't see if you've raised your hand, so.
So I don't see any more hands up, Erica. So I
Okay.
think that we hopefully address everybody's questions. If anybody does have questions, please chime in or raise your hand. All right, Erica, I guess you can wrap up the session.
All right. Well, I appreciate everyone's time. And I think the next session after lunch is on the how COVID is affecting us and how we're responding. It's a networking section, right, Paul, Chris?
That's correct. So as I said earlier, we're going to keep this room open. So if people want to talk or chat about things, you're free to do that. The next plan session, we do have the discussion that we'll have about COVID-19. And then our afternoon workshop begins at 2:30 Central. So the times I'm giving, I apologize to everybody, are Central Standard Time. So 2:30 to 4 o'clock will be material issues and wash factors. We'll have presentations by Chuck Kinzel, Lauren Cantley, and Mary Johnson. So I think that handles things for our morning workshop. Thank you to the speakers. Erica, thank you for leading the session and for introducing and monitoring the chats and the questions. This is our first time doing this, so you got to be the guinea pig and you were a successful one. So.
Yay!
But like I said, we'll keep the room open. As long as you see my camera on, if anybody has questions for me about anything, you can please feel free to ask. I mean, happy to talk about standards, happy to walk people through the eTextiles exchange platform, kind of show how to get in there, just in case you haven't seen it on your own, anything at all. So, but other than that, I think you're free until the afternoon session at 2:30 or the 1 o'clock networking session where we'll talk about COVID-19.
Awesome. Thanks, Chris. Thanks, everyone.
Thanks, everybody.
Thank you.
Excuse me, Paul. Can
This
you
is
hear me?
Paul.
Yeah, I just sent you a private message. Essentially, I want your email address. That's all. It would be great to connect over email so that we can discuss requirements.
Okay. Do you want my email address?
Yeah, that would be great. We can go from there.
PWAGNER
okay.
at MNWIRE.com.
Okay, so pwagner@mnwire.com. Okay.
Yes, sir.
Okay, thank you. Yeah, I'll reach out to you over email.
That'd be super. I am traveling today, so be aware. I'm going deep in the woods to hunt muskies. That's a big fish.
Happy hunting.
Okay, thank you.
Thank you.
Bye.
Oh, also really quick, do you see any promise in integrating this with technical embroidery and developing custom sensors in fabric, or do you think all the sensing should happen as part of the wire? I was just curious what your thoughts were on that.
Was that question for Paul?
Sorry. Yes, Paul. Sorry. Yeah.
Could you say again, please?
Yes. I was just asking. With textile embroidery machines and things coming up, with what Tamidul also presented, I was just wondering if you see any promise in merging the technology, such as your wire, with sensing fabric integrated into textiles, or do you think all of the sensing should also happen through the wire?
Well, I'm a wire guy, and I sell wire. I do 140 million feet a year. Most of our wire started with being tough and rugged. You know, the comfort came later, but the Army paid us to put wearable electronics on the body. And so they were having cable breakage. So all this technology came back from a small business innovative research grant, then some TTR, TIF, Title III money. So we've been very lucky over the years to acquire that. So I've got a prejudice. My goal is to make it as easy for the textile shirt and garment manufacturers to install something. I mean, that's really the bottom line. But I can tell you some pretty wild applications. You know, our divers are going down to 300 feet and they get hypoxia, like a pilot that gets into a spin and he's spinning so fast he loses blood in his head. And so they want SbO2 to be put on their masks when they dive that deep.
Cool. That's so
I never
cool.
thought of that. You know, these people just keep coming up with ideas. You know, we make cables for glacier sensors and they put them down 2,000 feet. Well, of course, when they shift, they break the cables, but not if they stretch. Well, who would know that you'd get a market out of that?
That's cool. No, I get it. Also,
So
I mean,
the fabrics is kind of a newer trend that I see. And they're probably 40% of our customers now in comparison to the last 10 years.
cabling's a real problem even there too, and particularly the stretch part I think helps out a lot. At least getting our initial prototypes done. So I'm just anyway. I'll connect with you over email. Thank you for dropping the email.
Sure.
Sounds really interesting. Also, I was just curious. So since you mentioned doing these custom sensors as part of the wire, I'm curious if you guys come up with your own data protocols, or do you leverage some existing protocols to talk to these different sensors?
Well, you got to
and
be
devices?
concerned with HIPAA. You know, that's for sure. They'll shut you down. You know, are you familiar with LoRaN?
Yes. The
Directional
low power-
Wi-Fi. You know, that's becoming much more popular, especially in the rural areas on farming, because they can control it. And, you know, DISA, HIPAA, and the DoD are kind of our guiding lights. You know, for our, we're aerospace certified, AS9100, and you got to go through that process to get anything on a satellite or into a jet. And so that's very tough. That costs us $200,000. And then they audit you every 6 months. But boy, they take over how you run your company and how you validate, how you teach brainstorming. Does it tie in with your financials? Can you audit all that? It's really, really intense.
Sounds like it, but sounds brutal too at the end of it. Thank you, Paul.
Okay, thank you, sir. I think I'm going to sign off. Good luck.
Thank you, Paul. Take care.
Thank you.
Thanks, Paul.
Bye-bye. Thank you, Chris.
So I guess I'll throw it out for anybody who's out there. Did anybody have any questions about the standards topics that I showed at the very beginning? I know we had to do a very jump through intro because of time, but I'm happy to talk about their standards activities. Stephanie Rogers is here. Stephanie is the co-chair of our general committee. So she's been involved. In fact, she was one of the people who got things launched for us with the committee a few years ago. So happy to talk about that. Happy to show anybody the e-textiles exchange you want to see. Topics are open to anything as well.
On the topic of standards, actually, it was similar to the question I was asking Paul. But I'm just wondering, similar to I2C and other embedded protocols, do you see any development of a standardized data protocol for e-textiles? Because all of us have these different sensors all over the body in our projects. So I'm wondering, do you see any standardization from a data protocol standpoint? which embedded developers and hardware designers need to be aware of?
So I know that there are discussions with other standards bodies around data. I think IEC is looking into that, and I believe ISO as well. IEEE is typically involved in those sorts of things. We really look at the electronic and the data interconnection for the products themselves, the materials that are used. But I mean, if there's something that our committee could do, you know, by the committee, I mean, so we have an e-textiles committee that is comprised of, I think, a couple hundred people representing different companies. If there's interest in developing a standard in the area, as long as we have a few companies that would be willing to at least start things off, and there's not another group out there that is working on a standard on the topic, then it's something that we could pretty easily get moving with. But Steph, I'm going to throw that one to you. We've kind of talked about it a little bit here and there with some of the standards development, but is this something that the committee should look at?
Yeah, I agree. I think we should be open to all of these suggestions, and maybe we have a new volunteer.
Yeah.
Oh, no. For that, I think, considering I'm just getting started in this field, but definitely, I mean, it's all interesting to me. But I'm primarily interested. I do like the data science stuff. I'm kind of looking at it as a new stream of data for me. So for me, it's laying down those pipelines kind of matter. Because I mean, all of this once this gets into larger scale deployments, it's obviously something in the age of privacy and all too. I do think it is a question worth looking into, and also, I mean, it's not just the data protocol. I think you guys probably have a lot on the connectors. I'm just wondering, is there any essential reading for textile connectors and non-solderable like interfaces with textiles and hard circuitry?
Relative to the data protocol?
Not to the data protocol, but more of a general thing. Just like good.
Let me get back to the data protocol for 1 second.
Yeah.
I've been noodling on the conversation more here now. It's interesting to me. I'm not sure exactly that the textile industry can help a lot in that, because we don't actually understand a lot of the data transmissions once the fabric is made, because it moves forward into an next step end process technology. But having said that, there's all kinds of other regulatory guidelines around traditional data transfer, and I would think a lot of that would apply regardless of how you're releasing them, you're mechanizing information flow. And so I think some of it might be very transferable. Again, I'm a textile person, so I might have absolutely no idea what I'm talking about.
Thank you.
Your second question, please repeat that.
Oh yeah, so I was just
connectors?
Yeah, the connectors. So is there any essential readings that people new into the textile part of it should be aware of for conductive connectors? And
yeah, there's a connectors guideline task group that has been meeting, and they are tasked with a number of actions and actionable items relative to getting some information out there. And so there's a committee on that, and I would really encourage you to look into that. First of all, make sure you're signed up with IPC, and so that you can receive information and become active in that. But yes, so the goal is to release some guidelines about that. The different types of connectors, the different materials of connectors, attachment techniques, things like that.
That sounds really useful, because I mean, right now with prototypes, it's like everyone's up to their own. There's like the lily pad style of embroidery, and then you have like pogo prints. So I'm just curious so definitely I look forward to it. But just adding to that data point, so the analogy I'd like to kind of raise is something similar to what they do in cars in the automated application. So they have these different sensors and actuators, so powered steering, all these individual components. So they have the car computer to talk to these individual systems through CAN bus and protocols. So I mean, while I do think some of it is transferable, I think with the body particularly, we have, so example for ECG. ECG is now becoming more of a system on chip kind of solution these days, where you just connect up the electrodes. As long as the analog part is done, you can kind of take the digital part and deal with it. So I was just thinking, like, is there? But problem is right now they all talk over individual protocols. I2C is slowly becoming more standard in terms of ease of use, because you can attach multiple sensors up to a same bus, and each of them have different addresses. But yeah, I was just thinking, like, if something tailor made. So I2C was made by Philips for the computer chipsets. So having the computer talk to like subsystems within the board.
Right.
But yeah, I was just thinking something more tailor made to the redundancies and use cases of textile might be interesting. So definitely,
yeah.
I think.
So one of your last 5 words was something that was in my mind. That's redundancy. All of those system infrastructures build for multiple tiers and levels of redundancy that I don't think we've sorted out yet in e-textiles, other than through maybe layering techniques like Lumia has been doing.
Yep.
Things like Butler Technologies. I think those layering techniques start to build layers of possible redundant data transfers, but I don't know that we're that advanced yet.
Okay, but yeah, definitely.
Yeah, just getting wires integrated into textiles has been, you know.
just throw the question on there. But
now
yeah.
What do we do?
But yeah, definitely. I think I mean, I at least hope it's one of the small things I focus on. But yeah, let's see.
Well, it's been a known, connectors for sure have been a known, you know, kind of issue, well, a known issue in resolving a robust system. And so it's definitely on our radar. And as you may presume before, a lot of companies are very close to the vest about how that is done. You know, there's a secret sauce. There's a lot of energy and effort in getting a robust system. And once you get it, to give it away is kind of challenging. You know, there's a right way to do that. And so companies are still navigating that.
Thank you.
Were there any other questions about standards or any other topics anybody wants to talk about? So I guess if there's really nothing else, so I'm going to turn off my camera for a bit. If anybody wants to chime in on things, feel free to do that. But we'll definitely get things rolling again in 30 minutes, 1 o'clock Central, for the open discussion on COVID-19. So we'll definitely talk to people then. I'm sorry, Joe Geiger, I saw that you just put something into the chat. Was there a question that you had? Okay, so we're at 1 o'clock Central. This is when we were going to start our planned session on COVID-19, how it has affected our industry and what's next. Stephanie Rogers, you are there, correct?
Hello, hello.
Hey, Stephanie. So I'm going to turn things over to you. I will put myself on mute, but obviously I'll be available for whatever you need.
Well, sounds great. Well, hello, everyone. This is a great restart to our afternoon session. Is just to collect as a group. And feel free to join in on your video as well. This is really more or less a talking session for everyone on the call. And we're just curious as to how COVID-19 has affected the e-textile movement, if you will, and what's next. What are people seeing as a way to sort of accelerate this? So I think I'll kick it off as the session leader. I can tell you that some of the areas of our proposed topics come directly from my experiences. This February, I was a recipient of an IPC award for the work we've done here on the e-textile committee. And then since March, I feel like I've abandoned it because the R&D priorities of the company in which I work have changed. And we reshifted into different market sectors, different applications for PPE. And it's been very intense as we shift markets and get new customers and make new products, and very demanding. I also am not a traveler any longer, and so I travel to my home office and sit down for 15 hours a day, like many of us, I'm sure. And so I feel like we probably share a lot of the same anxieties, but more importantly, what do you think about R&D priorities and distractions at this moment? And we can kick it off, I guess, with that question.
Hey, Stephanie, your audio was a little bit choppy there at the end.
I saw no. Did just get along?
Seems to be doing better now.
Okay. So I'm going to open the floor for comments. If anyone feels like they want to speak out about what their impressions are about the e-textile initiatives that may have been going on prior to COVID and the accelerations that were planned, and how things have either been postponed or for future date. Is my audio still working?
Still a little choppy, Steph.
I'm sorry. I don't know how to fix it. Well, again, this is an open forum. And we can talk about our experiences or our expectations moving forward. I know many of us are not traveling, as I mentioned. And how do you think that is affecting the prototype manufacturing and the ability to, be a maker in hands-on space? Is the communication improving so that you can show people in other places to do various levels of work, or is it, more challenging? Chris, I see a bubble on my screen that I am having some challenges. Maybe you would like to engage the talking portion of it, unless there's a specific question I need to answer.
So I haven't seen any specific questions come in yet, Stephanie.
Okay. I have this bubble on my screen because my speaker's not working.
So I guess a question that I would have is, I mean, I know that from the standpoint of the activity of our committee, we went from high level of activity through February to pretty much the committee members asking for a timeout through the summer months. There seemed to have been a lot of the, as Stephanie was saying, any of the activity or R&D that would have been in the e-textiles or smart textile sector suddenly switching over to people going and looking at different types of how to address PPE concerns and dealing with the different regulations at the state and the federal level. I'm curious to know if anybody out there has any input or any insights as to what your experiences were, any lessons learned, things like that. Okay, and I guess we're going to go to a question. Stephanie, I'm sorry, were you going to say something?
Sorry, it's me, Vignesh.
Yes.
I just wanted to share what we did on Mama. I'm getting feedback.
Well, we can hear you fine.
Okay. Anyway, so what we wanted to do was mainly after the lockdown started, even though it froze up a lot of our hardware development activity, we explicitly wanted to work on a face mask to monitor COVID. So we were kind of experimenting on decentralized hardware development and using online tools and tools like Miro and Slack mainly to communicate with each other. While we didn't get back to the original efficiency, I did think it did help a bit. So that was our experience anyway in our lab.
So I saw a question come in on the chat from Yolita. Yolita, did you want to speak out the question, or would you like me to read it for you?
I can speak the question. Hi, Chris.
Hey, Yolita, how are you?
Very good. Can you hear me okay?
Perfect.
Okay. Yeah, I was just curious. I know on our end at Flex, we had to make use of some more collaboration tools, specifically Zoom and so forth, which we had not been using as much during the day. But since travel has really been clamped down, it's been kind of invaluable. So I was just curious, I know the gentleman earlier just mentioned Slack. Are people finding those tools useful? Has the work slowed in the prototyping, or are you just managing it differently?
Was it directed at me? Sorry.
Oh, sorry, Vinyas. Yes, if you want to answer it, sure.
Okay. Sure. No, I mean, yeah. So Slack definitely helped. There was like a steep learning curve, at least for everyone to get onboarded, for me included. But eventually, once we got the ball rolling, it came back to something resembling schedule. But I still think it's a far cry from efficiencies we gain from in-person working. So I do miss that. But at least it helps some degree of work move along. But there is a decline in productivity though on my end, at least personally.
What about simulation tools? I'm curious. I know in other engineering disciplines, simulation tools are pretty standard for simulating the mechanical properties of a material and so forth. In textile, it's more difficult to do simulations because they're composites. They have so many different features to them. Any kind of simulation tools that this group is using, including Vignesh?
I personally haven't used any of it, but sounds interesting too. But I'm hoping to hear what others have to say.
Sure. So I've had limited experience with some textile simulation tools. It's actually been a secret passion of mine to have a textile FEA tool developed. And there are companies that have attempted to do similar things, and for different reasons. OptiText is a company that can input certain textile parameters and help drape analysis and then avatars and virtual fittings. So that's an interesting tool. And then in a more engineering sense, the company ESI group, they do a lot of manufacturing simulations and then component simulations where fabric is part of a component stack. And so I've seen some of that work done in car seats where there's a foam layer, a large foam layer, or some other kind of mechanical substrate layer. And it's a very good tool. But they are very engineering driven and it's not cheap.
No, thank you for bringing that up, Stephanie. You know, it's just something, a call out that or call to action to this community here is to have more simulation tools, because that can really help with the prototyping process and to keep the work going. I mean, we at our site is open for critical activities. We go in when we have to physically use a prototyping machine. But if we're doing design work, we pretty much do that at home just to keep the social distancing kind of numbers down. But I can still see this gap area in textile simulation technology, specifically when you start to want to enter characteristics, when you start to get into more complex systems, whether they're in cars or audio or on the body, you really need to put in different, mechanical characteristics like you do in mechanical engineering or electrical engineering. And that's kind of a real gap area in the textile industry.
Yes, it is. There's another entity, Keith, his last name escapes me at the moment, I should know it, Keith Hoover, who has been part of this group before and other industrial fabric groups, has an organization, Black Swan Textiles, and they are very much involved in machine learning and the manufacturing 4.0 and this concept too of virtual engineering of textiles. And so it's still a very long road. I mean, ask the color industry if they virtually approve color, and very few do, but it does work. But it's still a very hard thing to grasp. And only in times like this, probably, is it really getting more recognition.
So I see that Kunal put a comment in the chat about Microsoft Teams. I'd be curious to know about how you find benefit in Microsoft Teams for this, Kunal.
Hey, Chris. Idea is here. First of all, Vignesh, I, and Ghosh Devi, 3 are together over here, and because Vignesh was giving advice about the different kind of teaming softwares that you can use. So Microsoft Teams is one of them that we have actually explored both Slack and Microsoft Teams for project management. Now coming back to the software for simulation or any expensive softwares, what happens is that it is a subscription problems many times, that you cannot have those softwares. You can actually use it on so many computers. So for those kind of problems, what we do at the University of Rhode Island, and of course many industries they do too, that you can do a VPN remote access to a computer where the software is working. So essentially, you would provide your team members access to that software, and then you can use that expensive piece of software remotely from home. And that way, maybe, I don't know whether any simulation software can run in that way, but I believe you can do that. I mean, I would love to hear other people what they think about that.
Just a quick comment on, thank you, Kunal. Just another quick comment on the simulations. I have found when we have started to introduce textile simulations in the product development process, it is really helpful, actually, not just from an engineering standpoint, but also from a business development standpoint, to be able to cross that bridge and to show a customer, you know, this is the kind of problem that we're running into. We're working through it, but these are the characteristics that we weren't really quite able to meet. But, you know, through some more iterations or maybe adding in some design engineering changes, we can get there. So I find that the simulation process, the simulation softwares are kind of invaluable to be able to, not only from an engineering perspective, but also from an educational standpoint for customers.
Because seeing is kind of believing.
Exactly.
Yeah.
And are we talking only about the simulation on the digital side, or also you are looking at the physical simulation of this textile performance testing?
We're trying to do both, actually. Sometimes it's just at the material level, and then other times it's trying to understand how these different stack-ups are stacking up together, rigid and semi-rigid and flexible components. There just isn't enough data still out there. So we're sort of customizing our own equipment, to be honest. But, you know, it's just an area that I see. I see the value in the engineering standpoint, but I also see the value from a business development standpoint.
Yep.
It also sells it as next level thinking and not, you know, making pot holders anymore.
That's right. Yeah.
So I saw Maddie put in a +1 for Teams. Maddie, what's been your experience with Teams?
Oh yeah, so we also signed up for Teams. Well, we switched over to Teams at the beginning of the year, and we try not to use platforms like Slack, which cause a lot of interruption. So I think that Teams one is really good for having a central repository of information. And it has some chat features, but they're not super disruptive, which was helpful. So we generally use OneNote, Outlook for email. So OneNote for note taking, Outlook for email, Planner for tasks, which are all Microsoft programs, Microsoft Teams for calls, and what else is there? I think that there's another program we use from the suite, but you can kind of do everything with one platform, which we really like. So that's my, oh yeah, if you're using, you know, Word or PowerPoint or any of those programs, they integrate really well. So yeah, that would be my +1 for Teams.
So Robert, I hate to put you on the spot, but I guess I need to ask, who here on the call has heard of something called Basecamp? Anybody familiar with that?
No.
Robert, you maybe talk about Basecamp? It looks like Kunal is aware of it as well.
Right on.
Yeah, I'd be glad. Basecamp is it's a software that grew out of a software development company based in Chicago. Used to be called 37 Signals, and they did web development and that sort of thing. And in managing those projects, they decided they needed a tool, and they built their own, which then became Basecamp, which is now essentially what the company provides, is subscription-based platform for project management. Their whole philosophy from hiring to managing their company is as a remote organization and for asynchronous project management. So allowing people to work in different time zones at different times of day around flexible schedules. And so Basecamp is designed to facilitate that. It's a fairly basic platform. So if you're somebody that likes lots of bells and whistles, you will maybe quickly tire of Basecamp. But if you're somebody that says, we just need a simple, straightforward platform where we can place documents, where we can share messages, where we can collaborate. And as Maddie referenced, a lot of collaboration tools seem to be intent on disrupting whatever flow you happen to be in for periods of time. Basecamp is not that way. It's a very straightforward subscription model. I think it's $99 a month for unlimited usage. So, you know, it's kind of a simple platform, but based on the philosophy of being able to work remotely and asynchronously, it gives you the tools that you need. We've been having some success with it within IPC, and we're continuing to expand on its usage as we manage different projects.
So can I make a couple of comments on that too? Because I'd like to echo that.
Sure.
This is Claire at Propel, and we put in Basecamp about 7 or 8 years ago because we're always managing. It's almost like our business, every new project we have is a new startup. And so I was looking for a project management tool, and at the time searched the whole industry and tried out the free month of all kinds of things. And we settled on Basecamp. We're using something called Basecamp Classic, which they discontinued maintenance of, or I should say upgrades to some years ago. But I prefer it to the new one, partly because we figured out how to hack it and reorganize the way that they had organized it so it worked around our business culture and structure. And I was so glad that we had it in place when this happened, because it was completely seamless for us to move online because everything was online already. And my staff will tell you that, you know, I'm kind of always saying, if you have a document on your hard drive, it shouldn't be there. It should be in Basecamp. So we use it for every single document that relates to a project, all of the reporting, everything you can imagine. I've probably been on it a dozen times today. It's $249,000 for the completely unlimited, but we must have, I don't know, well over 100 projects that we've had over the last 8 years. And some of them are in the archive. That never goes away. I search the archive regularly. And I love its search feature. I can put in just keywords and it'll turn out everything. Birgit set up this wonderful resources site within it where we cross-reference any material we come across from a trade show or a meeting. And so if I want to find something, just use a generic term, Kevlar or a para-aramid, and see everything we've ever touched with para-aramid, the system will spit it out. So I'm just very thankful that we had that organization, because I don't count myself as the most organized person. This has saved my life several times over. Highly recommend. There are other systems. Last year I went and looked and did a search again, should we move off it? Partly because we have to move forward, because we're a defense contractor. We have to do something called NIST 800, and then we have to move forward to this new cyber security level next year, which isn't that onerous, and frankly, every business should be doing it. It's called CMMC. And I wanted to make sure to see if there was anything that I thought would give us more, and I didn't find anything.
I'd like to just finish with, even if you aren't looking for a different platform for communication, I know that's the question that kind of sparked this discussion, but if you look for the books that the founders of Basecamp, Jason Fried and David Hansen, have written, one's called Remote, one's called Doesn't Have to Be Crazy at Work. I think they've got 3 books out. They have a lot of philosophy and kind of tools around how to run a remote organization. And this is from a couple of company founders that have done it, you know, over a decade from the beginning. That was their intent. There's a lot of things that you can learn about how to best manage and collaborate when we're in situations where we're not physically together.
Yeah, just to echo that, I've read some of their stuff over the years on the blogs, and in the second book, you know, Work Doesn't Have to Be Crazy. And it's nice to do business with a company that has that kind of culture, because I'm a strong believer that your culture feeds into your products, and so that the person experiencing your product doesn't even, you know, they understand the culture from the way they experience it, even if they never actually talk to you. And that is the kind of Basecamp philosophy. They don't want to be the biggest or the best. They don't want to be the biggest or the craziest. They just want to do a really good job for all the companies that use them, and they do.
There is one more tool. I just was chatting over there. I provided Miro. That is a kind of very user-friendly collaborative tool for mind mapping and brainstorming. I would say that the people who are very visual and they like to kind of draw on whiteboards and create your nice charts and organizational charts or maybe structures of your work, flow charts and everything like that, which you normally do on whiteboard, right? When you are in person. Now, when you go into COVID, then you don't have those kind of resources that how you can have a collaborative drawing, because mostly you go on whiteboard and you write, but now you don't have that. So what we found in our lab, Miro, which students came up with this idea, and we did get the educational version of that. So we have kind of some advantage. But we found that to be really, really helpful because it goes into extremely real time that people can work together and create a chart, which I take maybe 30 minutes to create a chart. With students, you would have like in 5 minutes the entire chart ready. So I was very impressed by the performance of Miro and how reactive it was.
I've been finding in my collaborations the real testament of how people are learning and how people absorb information. With being, through camera like I am now, and email, chat sessions with teams, and then at our company, we are kind of agnostic in the video communications, and so we're open to any video communication platform. From wherever, from whomever, however we set up, including Zoom and GoToMeeting and Skype and everything else. Amazon Chime. And so that's been a real challenge because information is coming from every angle. Whereas I think prior to COVID, it was mainly email and telephone. And my telephone has kind of slowed down a lot, and all these other on-screen methods have ramped up. So organizing information has been a key challenge. And these tools are good opportunities to help sort that information. Thank you. So back to some e-textile topics around commercialization, recognizing that there's been some distractions in those moments. Do you think, I think actually based off of Paul's presentation earlier, that there might be an acceleration actually in wearables, e-textiles used in health. And so I thought that was, kind of a positive light on this particular topic. But at the same time, with issues with prototyping, hands-on, and maybe communication, the trajectory isn't fully identified, but the need maybe is now definitely identified. Does anyone have any inputs on the healthcare sector? Pratush, I might put you on the spot, knowing you've been involved in some areas of that market. The demand potentially is increasing.
Who were you putting on the spot, Stephanie?
I was going to say Pratush was still here.
I don't see him on the list right now.
Okay.
I would like to talk a little bit about this and would like to see whether people have comment on that. One thing definitely this morning we talked about was the development and testing of these devices designed from the textile materials, and also prototyping them. In e-health wearables, one of the major barriers and challenges are related to the human experiments, right? So you have to bring this technology on humans and actually validating this technology. Now it depends on the what the endpoints are, but this is something during the COVID time. So I'm kind of restricting our conversation over here to the only COVID time. Of course, in before it was kind of easy that you can have a collaborator on the medical side and would be able to do some validation. But right now with the COVID, the restrictions are really tough at the human experiment side. So I was wondering that if anybody here has experience of how you are validating your e-textile wearables for healthcare applications.
Well, I mean, just speaking from our point of view, our human subject testing that is the next stage of a project we're doing with the Navy is just held up until they can reopen their human testing labs. So we are on temporary hiatus on that, and there's nothing we can do about it. We've done all of the simulation testing we could do with heart rate simulators, etc. So we're carrying on with more extensive testing on durability, which we can continue to do while we wait. And I'm thinking right now we're slotted for first quarter of next year. I don't think that's going to happen. We'll see. So it could be, who knows how long before we get to human subject testing.
Claire, if you need any help and there is any potential collaboration, let me know. We in any ways we can help you with the validation side of that. But of course, we don't go underwater, unfortunately.
Well, this isn't just underwater. This is in flight simulators and goodness knows what, and real environment. We've done the part that gets us to that point, and now they're like, okay, it's beyond the relevant environment, it's into the real environment. And this really, I think at that point, there's nothing you can do. There's a lot you can do in the lab until then.
Yep.
Right.
So Kunal, this is Andy Schimler with Battelle, and human factors testing and study design is also part of our business. And this COVID has been a significant impediment for that. But we found a way to adjust our protocols, and now we're doing a significant amount of our testing extending into the homes of patients and finding methods to collect our feedback from in-home evaluations with different modalities like video and audio and even some remote controlled things. So we found a way after exploring a little bit to make some things work and continue our human subjects testing evaluations of products to allow the design cycle to continue.
Thank you, Andy. Just wondering that if I hear it correctly, so does it mean that you would be essentially giving the e-textiles or whatever those devices are, sending it home to the participants, and they would kind of collect data for you in remote settings?
Yep, that's exactly it. And we can we're doing in-home stimulation studies as well as evaluation of other products, and we're able to do it via video and other connected methods to get the feedback we need to allow design cycles to continue. So yeah, we're shipping product to them and allowing in-home evaluation, and then collecting the data like we would in our usability lab.
Excellent. Does that mean then you go with the, I'm sure you have figured out the whole way of training your participants and maybe how to maintain this device, how do you charge it and everything, right?
Yeah, training is a big challenge, and and sometimes part of the protocol that we evaluate is in following instructions for use. So there is some valuable feedback in more of a real-time environment than even we could witness in some of our usability labs.
Fantastic learnings, Andy.
Andy, I've experienced something similar in non-military user interface type studies where instead of bringing people to a central location, you contacted them individually and you know, outwardly shipped your materials or your test products. And so that feedback is actually now much more instant, and I think targeted and directed, and also is introducing even new user experiences, just because of the freedom of movement outside of that. And if you can account for that variation or extra input, it can be very helpful. One challenge, though, is some of team sorts. Those type of things are regulated, and certain performance ideas that go through a professional team sport cycle might be interrupted or delayed because of the availability of on-field practices and certain, you know, rules and restrictions that just can't come into play because no one's playing or not enough. All right, well, this is kind of, it's been a good conversation. I thought that maybe there'd be a lot more challenges, but maybe since we're all feeling the same way, there's no sense complaining about it. I think sharing the idea about the tools and collaboration was really fantastic. Some of those tools I did not know about, and I could probably use them. So that's super helpful. I do have a question, maybe just from a show of hands, if everyone wants to use the hands. I mean, I think, has everyone on the call gone to some kind of PPE category in the past 6 months? I think it would be kind of fun to know on an e-textiles call how we've been shifted around over the past 6 months. And then remind ourselves what we're doing at this event and what we're learning, and not to let it go after this as we try to ramp up and get back to our industry practices and our e-standards committees and getting things moving forward.
Stephanie, if there's time for one question, just a quick one, well, maybe not quick, I don't know. Is sustainability been a concern for people out there as far as just all the PPE that has to be used, and you know it's going to have to be discarded? A lot of that PPE is one-time use. What are people's thoughts on that?
Sure. Well, I know it's been a big topic in my world as a textile producer. And we're actually proud to be manufacturing textiles that can be washed and reused in the various PPE applications. Lots of times they don't fit the price point of the disposable products, and you have to start to justify the cost analysis of the reusable aspect of some of these products that can be reused. And that's sort of a, you know, it's a soft decimal point, because it's just new conversations and new studies that you have to get. It's, in other industries, they call textile costs soft money, because it's always so intangible to get an idea of what it takes to get to market. And so in reusable textile products, you know, that study is ongoing, and there aren't that many standards on reusable PPE. So I think it's just challenging overall in the company that I work for. I think that there'll be a lot of growth in, you know, in nonwovens as we continue, and hopefully there'll be some efforts to utilize compostable type yarns that when it is disposed of, it will degrade.
Yeah, I mean, Propel has been deeply pulled into PPE. I think it's partly because we had such a strong relationship with the Department of Defense. And so we received some funding very early on to assist in thinking, developing about PPE. I've also been involved with National Council of Textile Organizations, because we're a member of that, on their whole concerns about the PPE that is being bought and how it's not necessarily, the way things are being done is not necessarily supporting the US textile business. And I would just say that we, for a long time in the industry, have suffered from the essentially low-cost product that has flowed in, where the hospital systems have been hooked, is the only way to describe it, on disposables and not thinking about reusables. And I'm old enough and have been in this business long enough to have worked on reusable gowns, for example, when it was a thriving segment of the US textile business. And 20 years ago, it got completely undermined within a couple of years by very cheap non-woven products coming in from other countries. And I don't want to sound like I'm a protectionist. I'm not. I believe in a global economy. But I also know that we have created a bigger and bigger mound of toxic disposables that we're concerned about. So at Propel, we've made close to 2 million commercial reusable cloth face covers that we've shipped, and we're shipping every week, every day. And we've also turned our technical expertise into looking at what could come next. I do think that there are opportunities to combine PPE protection with e-textiles. I'm not quite sure what the products will be yet, but, and of course, then you get into this whole realm that was mentioned earlier today of FDA. Because all of those kinds of products, they're not currently regulating cloth face masks. They're allowed under an EUA, an emergency use authorization. But there will be a time when they start to become concerned about those and make regulations about those too. So it's an area, but the potential to, say, integrate sensing into it, or cooling or warming or whatever you want to do, that it's going to be something that we should look at. Right now, we're still deeply in the pandemic, and there isn't the time. So we were talking about how this has slowed down one side of our business, which is the e-textiles bit. And then on the other side, it's just been insanity. And I've never worked so hard. So if I can bring the two together, that would be really exciting. And anybody who's got ideas about that, I'm really interested in talking to you one-on-one as well.
That's really great feedback, Claire. Thank you so much. Yeah, I feel the same exact way. I have also never worked so hard understanding all of the various test methods and PPE products and end products and various aspects of the component manufacturing and how we can pivot to support that. And talk about an industry of opposites and challenges, from particle protection to breathability. They couldn't be more far apart. And textiles are doing their best. Well, nonwovens have done their best in managing that long awaited combination of performance. And since we haven't been involved in PPE for such a long time, we had to remind ourselves of all of those requirements and figure out how to do it all over again.
Thanks for those thoughts, Claire and Stephanie. And I was just going to add, I think we're all finding, obviously, that the term essential worker has expanded. It is our hospital care workers, of course, but it's the manufacturing workers too. So many of my colleagues have risked their lives and gotten sick, and it's just been really scary and heartwarming to see all these people pull together and try to manufacture so that the healthcare workers can keep going.
Yeah, I would echo that. I mean, the factories we've been working with to produce these masks, all in the US, we're using all US materials, of course, mostly made in Rhode Island, have just been fantastic. And the other thing is, these have been important jobs because we want to sustain this business. And one of the things that's going on that isn't really being talked about is that the Department of Defense is cutting orders on regular business for clothing and textiles, because recruitment is down, because the recruitment centers aren't open, and just they're not doing as many exercises themselves, so they're not going through uniforms. There's all kinds of things. So you've got this potentially serious threat to the sustainability, the existence, I should say, of the cut and sew industry in this country right at the time we need it to be doing more. And I would advocate for a national policy on PPE, and it is sadly lacking. There is no national policy on PPE for domestic production because it's a security issue, and we need to get that. So anyone who's interested in that, I'm interested in talking to them about that as well.
Let me know that if I can participate with something with you, Claire, because that is hugely important. And these trickle down challenges that happen and major markets dry up, and the U.S. textile industry is largely still the U.S. textile industry because of the military usage. So it's important that as things change with our military, that our U.S. textile industry can not only advance and grow, but just keep up.
Yeah, and the other thing about the defense sector is that it's also probably, well, it's definitely one that has funded a huge amount of the R&D in e-textiles that will affect everyone's life. It's really not just about the Department of Defense, but they're a significant customer. And they are relying on the US textile industry and the cut and sew industry, and whatever comes next, the new e-textile factory, which will be a merger of the two together. They're relying on that. They're relying on us to do that. But those businesses need to keep alive during this period.
That's right. And so much is lost if they don't.
We will be in trouble.
Yeah. I don't know if that's a good note or a bad note to end, Chris.
Well, this came up on those COVID-19 calls that we had over spring and summer. This was one of the early challenges. So just so everybody is aware. So back in spring, we were actually on one of our connectors guideline meetings, and the beginning of the meeting just shifted straight over to how the industry was responding to PPE needs for COVID-19. So what IPC did is we have a utility called IPC Works. It's an online collaboration tool that we use for committee development. And we actually use that for information exchange. So it was open to anybody to jump on. So we did a weekly, I think it was weekly at the time, we did a weekly web meeting similar to this. And then we had the online tool where people were sharing a ton of information. I think if there's interest within this group, then we can poll the group maybe a little bit later when we have more people on the call. If there's a need to reignite that, happy to do it as far as for the weekly calls, but also just to be able to give people access to that online community, because there's a lot of really good information that people were sharing up there.
Yes, it was a speedy location of PPE information for people that didn't know a lot about PPE. They could retrieve that. And new product information and sourcing information. I mean, I think it was just a very, very informative call each week, and then the updates and the connections even. Shout out.
Yeah, who knows Connie Huffa with Fab Designs, but man, Connie grabbed that thing and ran with it. So and she was really a fantastic catalyst for getting information up through the portal and out to people. So like I said, we'll put out a poll or a query when we have more people on the meeting, or maybe even in a follow-up, to see who would be interested in just getting signed on to the online group. There's no cost for it. This is a service that IPC is providing to the industry, even though this is outside of e-textiles, because it is affecting the e-textile supply chain. So I mean, it's something where we want to be able to use something that we have as a resource for industry to collaborate on things like that.
Outstanding. All right, gang, any more questions or PPE, COVID related? ideas and topics?
I have something to add. This is Salwa Rashid. I work for Jabil, and past couple of months I've also been working for. We've been also making masks and other PPE. So one of the most challenging things that I was working with the supply chain team. So basically finding all materials, and one of the most or biggest challenge was to find materials in USA. So that also showed how difficult it is to actually have a fully like a supply chain completely made in USA. And I heard Claire talking about producing in USA, and I would be interested to talk to her more about it, because I found it very difficult to find suppliers who have everything made in USA. In the end, we were able to find suppliers, and especially in the beginning, it was the worst when I contacted more than 200 suppliers, and then no one was having material, or they were already booked and no one had capacity to even take any more orders. But over the time, I think it has gotten better, and more and more people have, in a way, some industries have been affected. Some industries have also gained more business. So yeah, has anyone else also faced similar challenges?
Well, I would say to you that I would agree it's not necessarily easy, especially if you are not deeply embedded already. I suppose that's with the US supply chain, that's a little bit of the advantage that companies that do everything for the Department of Defense, because it has to be very compliant, which means grown, processed, and reprocessed fiber forward. We happen in Rhode Island to have a Rhode Island Innovation Textile Network, which has actually taken on a bigger role. There's a new organization called 401 Tech Bridge, which is linked to Office of Naval Research. And it's brought the Textiles Innovation Network together with the Composites Network, because we've also got a history of shipbuilding in this state. And then that's led to lots of very innovative composites companies. Anyway, I was able to lean on the Rhode Island Textile Innovation Network and long-term relationships. And the key piece for me was the nose stay. It was like, where am I going to get that? But we also have the remnants of the jewelry industry, the costume jewelry industry in this state. And for those of you who know the brand Alex and Ani, all made in Rhode Island. So I reached into the Rhode Island Manufacturers Association and found a guy who's just been amazing. We have all the elastic made, but there were things in short supply. And I remember sitting in my living room deciding I would order 500,000 yards of elastic in March before I had a single order, because I knew if I didn't place the order, I'd get cut out of the supply chain. And because that was the thing that was most difficult to get right then. So it was a little bit of like what's available, talking to people, going back in the supply chain. I was worried about yarn because a lot of the chemicals coming in are from offshore. And we've had to juggle at times. I have an amazing young woman working for me who she's juggling right now on orders. I can see it going on. It's like, where am I going to get this material, that material? How am I going to put it together? But there are some great resources around. You just have to connect in. NCTO is a great resource for that. And SEAMS, all of those organizations can help too.
Yeah, I was surprised too when you mentioned the nose wire. That seemed to be the most difficult material to find, manufactured in USA completely, to be very compliant. And it is surprising that it is so hard to find. It seems like such a simple material or such a simple thing, but it's one of the most difficult things to find. Well, yeah, we had to look in a lot of different industries too, moving away from textiles, which are not doing traditionally textiles, and look in other industries like automotives and other industries to find materials who would make similar kind of materials, but with some tweaking, they could actually make things that would work for a healthcare product.
Yeah, good old-fashioned metal bender is what we went to. And there aren't enough of them left. He actually told me he'd had more fun figuring out how to do this than he'd had in the last 5 years, because he said the Chinese had taken all the fun out of his business.
I think that's also good for US industries and manufacturers in a way. It's bringing them some more orders and business. and reducing dependency on supply chain outside of US?
Well, thanks, Claire. All right, Chris, what do you say? Are we ready to move on to discussion sort?
So if there's no other questions, I think this has been a good discussion. Like I said, I will send information for people if they're interested in signing on to the online group that we have. And Stephanie, maybe we can look into getting the meetings going again. Those were always really productive. And we'd schedule them for an hour. Sometimes they'd go the full hour. Sometimes it would be 15 minutes, all counting on what questions that people had. But it was a really good resource that people had available to them. But Stephanie, if there's no other questions at this point, then I think we can give everybody a break. Again, we're going to keep the Zoom meeting open. So if you decide that you want to talk amongst each other, please feel free. Other than that, the afternoon session will start in 30 minutes. So this would be a good time to take a break, check email, and things like that. But Stephanie, thanks for leading the discussion.
Thanks everyone for your input.